Okay. Check camera 1. Check camera 2. Check camera 3. Should probably turn the scope on. Head cam and side view cam. We are ready to roll. What's up, guys? Jason. First again. Were you first the other night as well? It's a completely different time of day. How are you first both times? So, how's it going? How's your day going? What are you guys up to? What's up, Steve? What's up, Strictly Amps? I was on your website the other day, actually, Strictly Amps. Thanks for your feature. You feature me quite a lot on your website, so I appreciate that. Thank you. What's up, Frank? What's up? Alwyn? How am I saying that right? Finally catch a live. Yeah, it's a different time of day to normal, so maybe we'll get some different faces in the live chat today. What's everyone up to today then? Tell me about your day so far. Slammed the notification message the moment I saw it on my phone. Well, you're one of the lucky ones that actually gets notifications, because so many people complain that YouTube doesn't notify them when I'm live these days, so you are one of the lucky ones. Okay, so yeah, I guess we'll get started. So we're still looking at this kicker ZR600 from the other day. Class AB, standard, very simple failure of the output section, just one shorted transistor on one of the channels. So replaced their removed the bad transistor, and the drive circuit is fine. However, it has gremlins in the preamplifier circuit, probably to do with this. A couple of people reached out and said that these have been an absolute nightmare. And cause lots of issues and headaches. So yeah, we're not getting clean signal to either of the channels as a result of probably some damage on this card. So reflowed all of the parts, all the connectors around here and stuff. So I think it's time to swap out the TL074C op amps on this board, which I think might be part of the problem. Still morning over here. Nice, nice. It's 8:25 in Jamaica. What kind of morning is it in Jamaica? Is it a nice sunny morning? Bit chilly, nice and warm, nice and cozy. Don't really know much about Jamaica myself. CD Bennett, how's it going? How's it going? Okay, so I think the first thing I'm going to do, actually, before we start, actually, you know what? No, let's start with the preamp. I was going to say I'll replace all the transistors first, because I've got some brand new TIP 35 and 36C transistors here ready to go into this channel that failed. But before we actually do that, I think we might as well get the preamp working first, hey? I think that would make more sense. Let's get the preamp working first, and then we can turn our attention to the just replacing the transistors once we've got that sorted. So I'm going to turn my hot air gun on and remove the TL074Cs. We did actually try replacing these the other day when I was working on this. However, op amps, generally the TL072, 074, LM211, 311, seem to be very delicate to high temperatures. So using the hot air gun to solder and desolder them, I have actually come across lots of problems with that, and only after soldering the op amps to the board with the soldering iron, like very carefully, so that you don't heat the chip too much. Only then have my issues gone away in the past. So I'm wondering whether there's something similar going on here. So I've ordered a bunch of brand new TL074Cs at great expense, because all the parts are expensive these days. And we're going to see whether soldering them manually to the board resolves the problems that we were having. If not, then there isn't really many other components on this board that could be causing us a problem. We've got the TL074s. There's some capacitors here, which are unlikely to really be the issue. This switch I've checked is absolutely fine. There's some resistors as well, which if they were bad, I imagine that they would show some visual signs of damage. Some other surface mount caps and stuff on here. So really, the only thing that I would really say would be bad would be the op amps. One thing I did notice is when we were slotting this into the board, giving it a twist like this did actually cause some changes on the output side of the amplifier. So I was assuming it was going to be connection problems on the main board over here, like this connector block, but we reflowed all of that. I've checked continuity, everything's good there. So I'm also starting to wonder whether it could actually be dodgy vias on this board, or possibly hairline cracks in the traces that lead up to these pads, these connector pads, even though they look absolutely fine. But we can get the microscope out and we can have a look, or I can just reflow them a little bit anyway. But yeah, honestly, I don't think that they're going to be an issue. Okay, let's remove the 074Cs from here as the first thing for today. Someone said it's snowing here. Must out and get it away. Damn, whereabouts are you? Where's it snowing? I'd love to have some snow. Most people don't like snow. I work from home, so I don't really mind if it's snowing. It's quite pretty. It's cold and wet in Louisiana. Jamaica sounds more fun. Sunny and warm. Nice. That's what we like to see. Thanks, Jason, for the good luck. Appreciate that. 7:27 where I'm at. Early bird. Wow. Yeah, I'm still sleeping at that time. I tend to wake up at about, I don't know, I tend to wake up about 8:30, 9. Okay, so that's the original 074s removed. I'm going to turn the hot air gun off because we're not going to be using that for fitting the new ones. We're going to go ahead and solder them with the iron just to kind of prevent any excessive heat from soaking into these ICs here. Is there much flux on there? I'm going to go ahead and refresh these solder pads. A little bit of flux on here. Almost run out of flux, but it's alright because I can order some more, because on a live stream a while ago when my flux was getting low, someone donated a very kind sum of money for me to get some more flux. So I'm going to go ahead and grab some of that shortly with the guy's very kind donation. So I'm not adding any more solder to these pads, I'm just leveling them because they have kind of mountain tops, peaks from where we removed it just now. So I'm just kind of leveling these flat. And this flux is honestly the best thing that I've ever used. It's just so good. It stays like crystal clear, and it remains its what's the word? It retains its workable ability. That's a shit series of words, but it stays working even after you've heated it a few times. Some fluxes, the moment you apply the heat, it's pretty much not usable anymore. But yeah, this stuff, you can kind of heat it a bit and it's all good. So I'm going to take the tweezers and I'm just going to line up this new 074. I'm just going to tack one of the pins in place to hold it down. Then we shouldn't need to apply any more flux before getting all the others down too. So let's just kind of hold it in place for a sec. Don't move. Oh, damn it. It moved. It moved and also tacked down. Okay, that should do it, I reckon. Just kind of nudge it over a little bit. And now let's tack down one of these other pins on the other side. Okay, cool. So now what I should be able to do is, I think we do need a little bit of fresh flux actually. Tiny bit more flux, not much, just a little bit of fresh flux. And then I can pretty much probably just drag my iron across these pins, and the flux will prevent any solder bridges being built. I'm also going to turn the temperature down on the iron a little bit. Put a little bit more solder on my tip. There we go. It's that one, that one, that's that one, that's that one, that's that one, and the last one over this side. Yep, that's good. Oops, sorry about getting in the way with my hat cam there. And then this side. That's that one, that one, that one, that one, that one, that one, and just reflow number one again. There we go, cool. So that is that chip all soldered on nicely. Do the same for the other one. Yeah, this is much more tedious than just doing it with the hot air gun, but it does alleviate any possibility that the hot air gun is damaging the ICs, because these are very delicate, these ones, for some reason. Okay, let's get that tacked on there like that, one pin over there. And same over this side. There we go. A bit of fresh flux. Okay. Okay, Beric said, guy brought in a ZX1000 to our shop, but it was too big to fit stealthily, so he bought a JL500/1. Amp was still good though. Oh, interesting. Yeah, the 500/1 is pretty cool. Not much power these days. You need a relatively efficient woofer to really have a good time with them these days, because woofers are getting less and less sensitive and less efficient because power is so cheap now. But they're really nice amps, the old 500/1s, and also the later 600/1s as well, based on the same circuit design. Just a little bit higher rail voltage, I think. Okay, that should be both of those soldered in nicely, and we don't have any risk of damage to these chips as a result of hot air gun. That one looks a little bit sketchy. I'm just going to flow that one. Okay, happy now. Happy now. All right. So we definitely have good 074Cs on here. One extra thing I'm going to do is I'm going to actually reflow all of these vias. So you see these little dots on this board that transfer the trace from the bottom to the top of the board. One thing I noticed is that when we flexed this little thing in the main board, it did cause pops and crackles on the main board, which it shouldn't really do, which could either be bad connection, which we kind of ruled out the other time, a couple of days ago when we did this. So it could also be that these vias are kind of cracked or maybe not so good. So a little bit of flux on the board where these vias are, and I'm just going to reflow the solder through them, which should make any bad connections be good again through these vias. Yo, how's it going, Matt? It's going alright, we just started. Just fitted some new 074Cs with the soldering iron this time, not the heat gun, just to alleviate any problems that might cause. Okie dokie. And let's have a quick look on the top side as well. Any that are accessible on the top side here I'm going to do as well. Some of them will be underneath components, which we can't get to, but that's fine. It should have reflowed from the bottom anyway, but just any that are accessible from the top, we might as well do that as well. Mark Lee, thank you so much, my man, for the 10. Holy crap. Thank you for the advice earlier. It's greatly appreciated. No problem at all, buddy. No problem at all. Thank you very much for the 10. Do you prefer your standalone heat gun to the one on your station? Well, the standalone heat gun is massive. It's for like preheating boards or for doing subwoofer recones, or you know, is for not accurate, not for, what's the word? It's for heating an overall general large area. So it's much more powerful. It's like 2000 watts, whereas the one on my soldering iron is probably like 60 watts. But it's obviously much more concentrated on the iron. Dude, Mark, thanks for the 20. Thank you very much, Mark. Really appreciate that. Don't give me a shout if you've got any questions or anything. Appreciate you, Mark. You're always jumping on the streams and getting involved. So yeah, thank you very much for the donation, buddy. Appreciate you. Get that nicely cleaned up. Frank says, Sam, is a Nav TV Zen V most 150 interface still available in the UK? I have no idea what that is. I'm sorry, buddy. What is that? It sounds like some kind of head unit or something, some kind of sat-nav unit. I can have a look on the internet soon if you like. Because of you, I have my own business now. Good stuff, man. It's great working for yourself, isn't it? It's really good working for yourself. It's a bit complicated with taxes, but it's yeah, it's a good vibe. Looking forward to the 3D printed boxes. 3D printed box you are going to do in the new videos. Yeah, me too. I'm so excited for this new series. So you can just use a sixth of the volume and hertz, and then it will be all real life results. So everything scales by a factor of 6, apart from areas. Okay, if you want to scale an area, like a port area, for example, or a cone area, then you need to do it by 6 times 6, 6 squared, because it's an area. So that would be 36, wait, quick maths. Yeah, 36. So if you want to scale an area, then you need to scale it by 36. If you want to scale a volume, so if you have an enclosure volume number in mind, like 3 cubic foot, then you need to divide that by 6 cubed, which is 216. So yes, one-dimensional things scale by a factor of 6. So the size, the kind of the diameter of a subwoofer cone, 12-inch, scales single as just one dimension, scales to by 6. Frequencies are one-dimensional; they scale by a factor of 6. What else scales? Yeah, frequency scale by 6 is one-dimensional. One single measurement, like the diameter of a cone, scales by 6. Areas like a port area figure or something will scale by 36, and volumes scale by 216. It's an interface to get the sound out of most 150 bus on modern cars. Can't say I've heard of it. It's probably because I'm not a installer. Okay. So this is with the new 074s fitted. So we're going to power it up, and I don't know, I kind of hope that this gives us nice clean sine waves now, but I'm a bit skeptical. I don't really have super high hopes. Although I'm not really sure what else could be wrong on that card, but it's got a feeling that it's going to mess around. The workbench is very messy today. I've been super busy with lots of different projects and stuff, so haven't really had a lot of time to come in here and give it a good old tidy up. And when I'm in here, I'm busy working, so yeah, there's like lots of dead MOSFETs and stuff everywhere. Let's see if we can give it a quick tidy. So there's the rails for this amp I'm currently working on. There's solder. There's my 074s. Let's put those over here in the tray. Yeah, this is all just like components. Like, this is all just like FETs that I take out and shove on here. So you just need to go through those and clean those up at some point. But I think for now we'll just crack on with this repair. Okay, power supply on. 10 volts going in. 31 hertz on the frequency generator. Let's see what we've got. So brand new 074Cs, all of these vias reflowed, all of these connectors checked for continuity and reflowed anyway. We should have audio output on this pin of the transistor. Let's just double check that there's no solder underneath. Yeah, it should be good. Should be good. Bias is down low. Don't want too much signal. Okay, let's power up. See what it's doing. Wow. So a lot of current draw. The power supply is screaming at me. So it's drawing more than 4 amps, which is not right at all. And that's because for some reason we have a massive wave on, we have a massive triangle wave on this channel. You see that? Huge triangle wave. Not sure why that is, but that is causing excessive current due to probably cross conduction between these transistors. There's nothing on this channel over here. If I remove the RCA, we still get massive triangle wave on this channel for some reason. So, you know, I'm willing to bet that there might actually be a fault on the main board then. If we remove this card here, disconnect this from the circuit, power it up, we no longer get that massive triangle waveform there. And actually I just remembered on this amplifier, I do actually need to clip my ground probe onto the output side grounds to read everything correctly in the output section. So yeah, without this card fitted, we get correct operation, 1.2 amps worth of idle current draw, no weird stuff going on either channel. What we have going into this card on these pins here is we have, well, we don't have any sine wave connected on the RCA, so let me just hook the RCAs back up and turn the signal up a little bit. So we should see a sine wave going in. Yep, there's a sine wave going in there. There's our DC voltage. So we've got one sine wave going in on this pin here, which looks nice and clean. So this card is being fed with a nice clean sine wave. As for what comes out though, it seems that we get a bunch of nonsense coming out of it. So we still get a nice sine wave going in, DC. This pin here has some kind of high frequency noise coming out of it. This pin here has DC voltage. This pin here has a very small high frequency noise, which you can see on the scope there. This pin here, DC. This pin here, nothing. And oh wow, that pin there has huge square wave or something. Yep. So that definitely shouldn't be there. So there's definitely must be a fault on this card here, this little preamp card. But it's such a simple card. Apart from the 074Cs, which are brand new, there isn't any other real components on here. Like just capacitors and resistors, which are all likely fine. Like 31 kilohertz on there. It's very strange. Okay, one thing we can try doing is we can try and bypass this card to determine whether this is the thing that's causing the issue or whether it's something further down the circuit that's just kind of influencing what's happening on this circuit. So we've got audio input here, and then on the pin below it seems to be the audio output, and this is for the, is this the right hand channel, I think? So whichever channel this is, left hand channel. Okay, so left hand channel has this great big square wave on it. If we remove the RCAs, it's still there, I think, isn't it? Yeah, it's still there. But what we can do is we can go ahead and just bridge over those two pins on this card here, and that should bypass this card. I want to do the same thing as well for the right hand channel, so I'm going to plug the RCA into the right hand channel now and remove this card, see which pin is responsible for the right hand channel. So that was left hand channel. Right hand channel, is it maybe going to be symmetrical on the other side? Yeah, it's symmetrical on the other side. I suspect that the output for that is also going to be directly underneath it. I suspect we have symmetry here. Okay, so let's remove this card for now. We're not sure whether it is actually faulty or whether there's something else on the main board that is causing a fault to arise when this is in. We're going to go ahead and bridge over some of the pins on here. If I can get this kind of, maybe I can stand this up so you can see what I'm doing somehow. Yeah, I can stand it up. I just need something to kind of hold it in place. What do we got? What do we got? Need like a don't think I've got anything in immediate reach, but basically what we're going to do is we're going to bridge over where are we? These, here we go. So this pin on the end here is the left hand RCA input to this card. The one below it appears to be the RCA output, and then we seem to have symmetry with this side being the RCA input for the right channel, and therefore I also imagine we have RCA output for the right channel down there. So we're going to bypass this this board and just run a little jumper wire between these two pins on the end here and these two pins on the end here. So let's see if we can do that. Just need to grab a couple of little jumper pieces. I usually have a bunch of spare jumper pieces up here on my desk. Here's one. Just put a bit of flux on these pins here. Okay, that is one set of those pins bridged over, so now we need the other one. Okay, that's the other one. So provided my thoughts are correct, that now should bypass that module. And we should, provided that that's the only issue, if the module is the problem, then we should get audio now on both channels. If we do get good audio on both channels, I think what I'm going to do is give the customer a choice. I'm going to say, look, what I can do is I can either leave this module bypass. All it does is it just introduces a fixed low pass filter. So you could just do that on the head unit or something if you wanted to. If we do that, then this repair will be cheaper, because obviously I haven't got to go ahead and diagnose this pile of crap. If, however, the customer wants this functional with low pass, high pass and bypass working, then it's going to be more expensive repair. So there's two choices there for the customer. Also, I suspect that the 074Cs that we removed were likely working absolutely fine. So I'm going to put those in my spares drawer up there. Did you reflow the daughter board top pins to the motherboard top pins when you reinstalled? I don't remember seeing that. Do you mean these ones, like to the traces? I reflowed all of the pins on the main board that have anything to do with this this daughter board thing. So alright, let's see what happens now then. So we think we've got that bypassed, so let's apply some power, see what happens. What's it gonna be? Is it gonna be something smelling? Annabelle says, I have the 1000 series of the same amp you have. I still haven't figured it out. Oh heck, well if we figure this out, then maybe that will be the same issue on yours, Annabelle. Alex the Amp Guy says, I say like one of the repair manuals I have for one of my amps says, if the amp's not working, you need to determine what's wrong and you need to have soldering iron and desoldering tool to fix it. Nice, useful, useful. I remember this style of amp had an optional bypass card. Maybe you can find a picture of one for circuit design. Yes, maybe. I think the other ICs have a feedback to the card, if I'm not mistaken, said Anibal. Well, maybe that's the issue then, and bypassing it like we've done here isn't the solution, and we might have to change some other op amps on the main board. No, for the riser to the mainboard, yes. Every single connection from the riser to the mainboard has been reflowed and resoldered, you know. So that's all good. All good. Right, cool. Let's apply some power and see what we got. So I'm not going to add any RCA signal yet. Just want to make sure that that high frequency crap from this channel has gone away. Okay. No more high frequency crap. Cool. Okay, so let's plug in an RCA and see whether we get audio to either of these channels. We do! Look, there's some nice clean audio. So yep, there's audio on the left hand channel. So let's go over to the right hand channel. And yeah, we've got clean audio there as well. Rare! So, what the f***? What the f***? Wait, I might have a button for this. What the f*** is actually wrong with this card? There's not really any components on here. We've replaced the two ICs, which are the 074Cs. This switch, I have confirmed, is all good in the hood. We have a bunch of resistors on here, which I would imagine if these were bad resistors, then they would show visual signs of damage, right? Let's get out, let's just for fun, let's get out the microscope and let's have a real detailed look at this bad boy. Just to see if we can see anything untoward on here. Brush the dust off it a bit, I barely use this. Welcome. Welcome. Welcome to your microscope. Okay, let's get it in focus. So let's first of all have a nice zoom in and let's have a detailed look at these traces going to these connector pins. Okay, looks good. Although kind of hard to tell. There could actually be a hairline crack there. So maybe I'll actually try scratching back and reflowing some of these. Looks okay. Looks okay. Looks okay. Looks okay. Flip her over. Looks alright. Looks alright. Looks okay. Looks okay. And looks okay. Alright, let's have a look at some of the resistors to see if any of them are looking kind of bad or janky or anything like that. So I've got a surface mount cap there. Man, these light torches do like to flicker, don't they? Alright. So if a resistor is a high hang on a minute. Hold on just a minute, friend. I think I found a goddamn problem. Hey, come take a look at this, man. Yo, get your ass over here. Take a look at this goddamn resistor. You see that? You see that crack in that resistor? I don't know about you, but I see that crack. I see y'all that crack in that resistor. See that? Now that right there is a bad solder joint. Hell, we gotta get that reflow. Look at that. Oh, man, my doublet, that's moving. That's moving. I touched that resistor. I see it moving against that solder joint. Hell nah. That's some stanky shit right there. We gotta get that reflow. Hell, we wouldn't have seen that if we hadn't got this goddamn... We wouldn't have seen that if we hadn't got the microscope out. So it's time to reflow this bad boy. Time to get reflowing then. Heck, I would not have seen that. You can't see that with your bare eyes. You can't see that with your bare eyes. Look at this. So this is kind of this is kind of what you see with my eyes. No way would you see that hairline crack in that resistor. So awesome. That's got to be what it is then. So let's reflow all the resistors and caps on this board. Reflow the whole goddamn thing. And that should be the solution. Elliot says, check every part on the daughter board, even if it sounds excessive or stupid. That was the solution. Elliot, nailing it on the head. Oh, shit. Right. Let's get to reflowing everything on this daughter board then. I'm going to reflow every single goddamn component. I guess this makes sense because this board is handled like, you know, it's kind of just floating in this connector here, so it might suffer from vibration a little bit, you know. So it does kind of make sense that that might be cracked there. Yo, Matthew, chill, man. A 50 from Matthew. What a legend. Thank you, dude. Can you show my slapping new sub? Yes, we can. So, I picked up an Alpine Type S the other day. Check out this bad boy. Oh, heck. Look what you made me do, Matthew. You made me spill my pistachios. I'm not even joking. I'm actually not even joking. Excuse the mess for the minute, but you made me spill my pistachios. But I picked up this Alpine Type S in a sort of job lot. There was a sub amp box bit of wiring for really cheap on eBay. So there's this nice Alpine Type S. This is actually a really nice sub. I actually quite like Alpine. This is not super high power, but there's some really nice engineering gone into the subwoofer. It is a bespoke design by Alpine. It's not just something off Alibaba, AliExpress that's just pumped out by some Chinese build house. Alpine have actually engineered this. This is a pretty nice sub. You've got their really cool rolled surround here, ribbed surround, which actually does make a difference and does work. This woofer has pretty damn high excursion for the amount of cone area that it has, so that is a massive plus. The spider is really well designed and doesn't suffer from the hairline cracks that you tend to find with normal kind of cheaper spiders. Decent coil is underhung design. You've got dual voice coil with all the terminals on one side. You've got this little beauty plate here that hides the screw holes, so it looks really nice. So all the screw holes go under there, and you've got this nice little beauty plate. So I'm selling this to my good friend Matthew here in the live chat, and I'm pretty sure he's bought this sub like 4 times over with the amount of donations he sends in. Thank you very much, my friend. But yeah, so absolutely, we'll show this sub bumping on this kicker, provided we fix it. David said, you have me LMFAO. I wish all Southern men had the magical skill to switch to a British accent. Yeah, flip it the other way around. Imagine someone tuning in at that moment just as you went American. I have 3 crossover boards. They all have damage. Somehow I have not had time to check them out. I believe it could be vibration damage on them somewhere. I suspect so. The fact that I found this vibration damage, I would say that, yeah, these are probably very susceptible to these cracked solder joints. So if you've got any of these and you haven't got the microscope to check them like that, then just go ahead and reflow all the connections on here anyway. So the op amps wasn't dead. Yeah, Frank, it seems that they weren't. They seemed fine. I've had an Alpine Type R Dual 2, which I've had for 15 years. You can't say that about a lot of brands of subs lasting 15 years. Nice bridges on the clamps. Oh yeah, that's for basically wireless operation. This Type S, actually it doesn't document it in the manual or anything, but you can actually run this wirelessly. You just do that and it kind of acts as an antenna, and you have to have one of the Alpine PDX amplifiers, and you can take the board out and there's a switch underneath the PCB. You flip it to a special mode and yeah, basically you can run the sub wirelessly. It's pretty cool. Okay, cool. Let's get reflowing. You know what I wish, right? I wish that we could play music on stream. So times like this when I'm just kind of soldering, we can just like, people in live chat could like choose music. That'd be so sick. Oh, there's another one. Did you see that capacitor just like fell off? What's the one? I melted the solder on one side of it, and the other side was not even connected. It just kind of fell off. So yes, I suspect that these suffer quite badly from... Oh, there's another one! This resistor as well wasn't connected on the other side. This one as well. This resistor wasn't connected on the other side. There's a bunch of components here that are not connected. That didn't really show any visual signs at normal eye inspection, but the microscope... Oh, there's another one. The microscope told us all we needed to know. Yeah, basically all of these parts are snapped. Like, I'd say 9 out of 10 of them have bad solder joints over here. They're gonna make me lose my mind up in here. Why not use royalty-free music, i.e. Incomptech? I have never heard of that, but if such thing exists and I can actually play that on my live streams without any problems, then that would be pretty cool. Provided the music's good, of course. Like, that's the thing, royalty-free music isn't always that great. Although I have had a mess around with Epidemic Sound because I've been looking at using some music and some tracks for my new sort of video series and stuff. So I've been looking at Epidemic Sound, and honestly, some of the music on Epidemic Sound is freaking awesome. Really, really good, well-produced, nice sounding tracks on there. So yeah, I guess royalty-free music can sound good. But that's obviously if you're paying for it. So yes, it's royalty-free, but you have to pay for that luxury. Whereas free royalty-free music, I suspect there's less chance of that actually being any good, because I guess no one's getting paid from that. Old computer game music. Well, actually, computer game music as a whole doesn't really seem to have any copyright issues with it. Like, I've used computer game music from all sorts of different games on some of my videos in the past, and it doesn't get flagged on YouTube, yada yada, seems fine. So yeah, video game music actually is not a bad shout. How did the live stream remote repair with another viewer go in the end? You haven't missed it. There's a few guys I was trying to get it set up with. The problems were the other guys, either it was their setup, their cameras and stuff, the way that their cameras were positioned, made it very difficult for me to see what was going on, and also their connection quality was very bad as well. We suffered from just basically a pixelated mess that I couldn't really see anything that was important, and also had an issue with getting their video feed live on my channel with OBS was a bit of a headache as well. So yeah, it was just a bit of a headache getting a good enough picture on stream from them to you guys on YouTube. So I'd love to still do it at some point. Maybe I just need to research some more programs, some more video conferencing services, etc. So all right, so that, I think that's all of these parts reflowed. There's actually one capacitor that I just need to reposition. I think that's every single component now reflowed. Yes, I would say that that is. So I just need to reposition one capacitor that moved a little bit here. Going to do that with a hot air gun. Then we're going to remove our jumper cable things from the main board, and that should be working okay now. Oh my god, Sam! Put on a PlayStation Jungle Mix. I forgot the name of the YouTube channel, but if you search it, you should find it has so many views. It's so sick. That's maybe worth checking out. I don't know if everyone here likes jungle though. The idea was to get people in the live chat to choose music. That'd be such a cool feature, wouldn't it? If you could have like live chat jukebox, so I didn't have to do it. You guys just put music on, and I was like, "Yeah, this is a pretty cool track." And you could all be like, "Yeah, that's dope. Nah, that sucks ass." Could be cool. They see me flowing, they hating. It's more intelligent DMB and stuff. I like that word, intelligent DMB. Some electronic music is kind of a bit mindless and just kind of repetitive and not really much thought put into it. But some dubstep, some drum and bass, some especially glitch hop and stuff like Cohen sound. Ah, man, the thoughts put into basically every sound that you hear, every stab, everything you hear, the thought put into that, and the musical intellect is actually very high. Sam, you can use Nightbot for song requests. I have no idea what Nightbot is. I see it in other people's streams, but maybe I should have a look at that. People add songs to the queue and it also plays them in order. That's pretty awesome. Bring back dubstep. Man, dubstep never went anywhere. You just got to know where to look for it. It never really went anywhere. It's still absolutely alive and kicking. The only thing that doesn't exist so much for dubstep is like you don't tend to find it on a night out in commercial places anymore. Yeah, dubstep is alive and kicking. Is leaded solder softer and better to prevent flex issues? Yes, leaded solder is just much better in general, apart from the fact that it's lead. So, oh, bro, no, it's just the name of the genre. Oh, okay. I hadn't heard of that as a genre name. Do you like Knife Party? I used to. Haven't listened to their stuff in years. Used to like Knife Party when they were like the Tang, the thing, you know. All right. All right, then. So fingers crossed. Now, if we slap this back in the board, that should be all working now. If it's not, then I'm not really sure what else to do apart from just give it back with a bypass. All right. Power supply. Yep, I think we're safe to power up. There we go. Nice clean sine wave. Let's check the other channel. Hey, nice clean sine wave. Oh, no, there was a nice clean sound wave. Where's it gone? Oh, there it is. Okay, whew. I think my probe just slipped. So yeah, cool. Both channels now working. So the issue with this preamp section the whole time was bad solder connections on the surface mount components, which I probably should have checked earlier, actually. I always forget that that's a really common thing. Yeah, bad solder joints on surface mount components. Just saw your sub design video, and I wondered if you have seen the L-Acoustics KS28 subwoofer with its flared port. Let me have a cheeky look at that. Let's bring that up on the old Google machine and see what we're looking at here. Is this the right thing that I'm supposed to be looking at? I can't really tell a lot of what it is. Are you talking about this flared port thing here? This little curved bit here? I mean, yeah, it looks like a box. I can't. I guess I'll need to have a look inside it really to see any more about it. But yeah, it looks pretty cool. Yeah, bypass bridges are removed. That was done. So yeah, this amp's all good now. One thing we do need to do though is we need to fit the new output transistors and then bias it. So if you don't know about biasing Class AB amplifiers, this will be useful to you. So let's drop all of these out here. That one, so we need 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. These all need to come out. So yeah, these transistors, although they read fine on the tester, they're going to go in the bin because it's clear that they were subject to some stresses when this amplifier failed. One of the transistors was really, really high on the HFE, on the current gain, so yeah, might as well just bin these ones. Tube amps need biasing too. I know absolutely nothing about tube amps. I've never used one, never repaired one, never even looked at one really. I don't think I'm a tube guy really. I know the basis behind tube amps. I know that everyone says they sound amazing, but I don't think I'm really gonna be a tube guy, even if I was to listen to one. But I haven't listened to one really, so I can't confirm that for sure. But I just don't think I'm gonna be a tube amp guy. See what I have got though. I've got a little tube preamp. I've got a I can't remember what the brand of it is now, but it's a little headphone amplifier or preamplifier that has a couple of tube slots in it, and I've got some. One, two, mic check. Hi guys. Sorry, not sure what happened there. All of my USB devices on the PC just disconnected for a moment then. Not entirely sure what that was about. But basically, Windows just went like disconnected all of my USB devices. And yeah, okay, we're back. I think we're back. All of these cameras still working. This one's not working. Side Input capture, scope cam, snake, SFX, spectral G. That was weird. Not sure what that was about. This one's still working, although it's turned green, which happens sometimes. There we go, it's still working. Cam's still working. Okay, scope's still working, I think. Oh no, the scope's not working anymore. I think the Logitech webcam driver just crashed. I think that's what it was, and it took out a bunch of the other USBs as well. Okay, cool. That Logitech webcam's come back. Yeah, scope cam's come back. Okay, must have been a weird USB glitch, something like that. Anyway, I'll tell you what it could have been. It could have been a oh, what do you call it? Bit flip. It could have been a wow, shit. What's it called? The radiation thing that flips a bit. I can't remember what it's called now. Did anybody else see Sam remove the jumpers? Yes, I removed them. Yeah, the card's working properly now. So, Annabelle, if you are experiencing similar issues with these, then reflow every single surface mount component on these crossover cards, and that should resolve your problem. Yeah, it's really cool. Bit flips are why aeroplanes have multiple computers. Well, bit flips aren't the only reason for this, but one of the reasons that aeroplanes have multiple computers for each critical system that are constantly comparing data with one another, and if one of them or if one or multiple of them have discrepancies, then it will favor the data that's in the other two. So, like for example, I think one of the critical systems has 4 parallel computers, and basically, if one of them has suddenly a different data set or has a variance in its data to the other 3, then the one that's different will then be resynchronized with the other 3. Because it's going to be near impossible. I'm not going to say fully impossible because nothing is fully impossible really, but it's going to be near impossible for 2 of those computers on the for 2 of those computer units to get a bit flip at the exact same time on the exact same bit. So if you've got 4 computers there running a system, even if 2 of them got bit flips within a short space of time, they're going to be different ones, so they're going to be affected differently. So then the data can be compared amongst all 4 of them, and then it can be reset to equilibrium across the 4 of them with the correct data. Same thing applies for spacecraft, shuttles, satellites, I think. Faster says, how do I donate for supplies and beer? Oh, thank you very much, man. I appreciate the asking how to donate. One way is you can send a super chat on YouTube, but YouTube does take 30% of that. I think that, yeah, I think they take 30%. So if you want to donate without YouTube taking money, then you can use PayPal if you want. Okay, so that's all of the transistors out of the side that had the failure, so now I just need to load up the new ones. So it's going to be 36s along this side, 36C along here. So let's drop in our 36s, and our 35s along this side. I have to say, guys, it's a lot more fun repairing stuff with you lot here. I really do enjoy this. I've not really been streaming a lot of repairs recently, just because I feel like I try and get through them quicker when I'm not streaming, because I'm not talking and explaining what I'm doing at the same time. But honestly, it's so much more enjoyable with you guys here. So thanks for sticking with me here. Oh, someone mentioned float plane. I did look at float plane. I wasn't sure what I had to do though. If like I haven't really looked at it that much, but if I wanted to sign up for float plane, I think I have to pay something to sign up for float plane. But then also users pay for my content on float plane. So maybe float plane will be the place for me to do my amplifier repair tutorial, like my full actual structured tutorial that I'm planning to do, that goes through in detail every different type of circuit, all of the things I've learned over the years, all the tips and tricks and stuff that fails often, how to diagnose different circuits and stuff like that, all really well structured and laid out. Maybe float plane is the place to do that. I was looking at like Patreon or whatever, but Skillshare? Never even thought of Skillshare. I got Perry's Guide a couple of years ago, but still want to learn more. Yeah, Perry's Guide is really, really good. It's really thorough, but Perry's Guide is quite dated. Doesn't cover, especially the Brazilian stuff, doesn't cover the new Brazilian stuff at all. So many really, really good repair tricks and stuff that you need to know about the Brazilian repairs that isn't covered on Perry's Guide. And also just extra stuff that I've picked up over the years that isn't on Perry's Guide, like common failures that aren't covered, or diagnosis methods that aren't covered on there, things like that. We may need to rebias the V60 again. It does run super hot now, so we might have biased it a little high. So yeah, we can knock the bias down a little bit. The way that you know if the bias is set too high is if it runs super, super hot even when it's not doing anything. So even without a speaker connected, if it gets really hot after sort of like 10-20 minutes of just sitting there turned on, then yeah, the bias is too high. Where do I buy my components? I buy my components from two shops here in the UK, RS Components and Farnell, and occasionally from a shop called Mercatio, which are kind of like a, I want to say like a comparison website, not really a comparison website, but they don't hold stock themselves. They sell stock on behalf of other distributors, and yeah, you just kind of pay for it through Mercatio, and then they send a request to have the stock sent over to you through them. And sometimes it's cheaper through Mercatio. Yeah, guys, if I was to do an amplifier repair guide, what should I call it? Someone suggested Sam's Guide. I could call it like Bear in Mind, because bear vids, and you want to bear a lot of things in mind when you're repairing amps. I could call it Bear in Mind. I could call it Stanky Hot Fets and Stone Cold Sauvignon, just like my Discord was set up with, because that's a really cool name. When you fixed that Rockville amp that was nowhere near its rated power, did you upgrade the MOSFETs or leave what was originally in it? I can't remember, honestly. It was such a long time ago now. But upgrading the MOSFETs doesn't really do anything to the amplifier. It doesn't make it automatically produce more power. The MOSFETs that will be fitted to an amplifier from factory are 99.99% of the time more than capable of dealing with whatever currents will be flowing through that amplifier under normal circumstances. So upgrading the MOSFETs doesn't do anything really. In extreme cases, it might help the amplifier to run cooler, less hot, if you're demoing for prolonged periods with low reactive load, or wiring down lower, or if the MOSFETs themselves are the bottleneck when it comes to wiring the amplifier down to 0.5, rather than, for example, the transformer, then fitting better MOSFETs can actually turn that amplifier into a 0.5 stable amplifier, but it doesn't make it do any more power from the get-go. So really, unless there's like an actual reason for you to be upgrading the MOSFETs, the extra cost just isn't worth it, because it won't make the amplifier perform really any differently than what was in there originally. The stank. I could just call it the stank. I quite like that. Samplifier repair. It's not too bad. Burying my amps for you. It's quite funny. Burying amps. Someone said, yeah, I burned it out at 0.5. So if you burn out MOSFETs wiring down to 0.5, then it could be the MOSFETs that are the bottleneck, but it also might not be the MOSFETs that are the bottleneck. What might be happening is that the excessive current might be saturating the transformer in the power supply. And when the transformer saturates, it basically presents a short circuit to the power supply FETs. So even after you upgrade the FETs, if the bottleneck is the transformer saturating, then the upgraded FETs are still going to blow. So yeah, you really need to figure out what is the bottleneck there, and there's not really a super easy way to do that. You could work it out based on the thickness and the turns and stuff like that, or you could maybe try and get it on an oscilloscope and probe all the waveforms as you increase the current across the outputs and see what happens to the waveforms on the power supply MOSFET drains, for example. But yeah, it's not really an easy way to tell that nice and quickly without doing a bunch of tests. Okay, so there's our new transistors fitted in the bad channel that was on this amplifier. I'm just going to kind of clean this up a little bit, get rid of some of the flux. And yeah, then we're going to get to biasing it. Now it's very important, if you're going to bias an amplifier, it needs to go back in the heatsink. Don't bias an amplifier when it's not in the heatsink, because you're going to have a bad time. It's not going to go well. Okay. So, let's grab the heatsink for this thing. And let's throw it back in. And the bias position for each channel will now be different because the transistors that we fitted are different. Well, they're the same model transistors, but they'll probably have a different bias position compared to the originals. I also need to yeah, MIDI to key. When my USBs dropped out, it also killed my little Akai thingy here. Close that one. Wait, has my keyboard stopped working? Nope. Right, there we go. it's looking good. All right, slap you back in there. Okay, cool. Let's get that lined up. Actually, there's a couple of things we need to put back in first. There's a couple of... Where's the other one? There's a couple of these little upright mount things that need to go in. Don't what without putting it back in the heatsink? James, don't bias an amplifier. So biasing an amplifier, Class AB amplifier, means you adjust the overlap position between the NPN and the PNP transistors for the channel. So on a Class AB amplifier, half of the transistors create one half of the sine wave, and the other half of the transistors create the other half of the sine wave, and in between those two halves of the sine wave, there needs to be a little bit of overlap where the two different banks of transistors actually are turned on at the same time. And the amount of bias is the amount of overlap between the transistors. The more overlap you have, the less distortion there is at the crossover point, but the more biasing you have, the hotter the transistors will run at idle, because they're actually on together at the same time for a fraction of a moment, therefore they kind of power each other. So there's a sweet spot between getting just enough bias that the distortion is nice and low, but not too much bias that it just runs really hot. So that's what we want to try and calibrate here. And I just need to grab the other mount for the heatsink here, which should be on the floor over here somewhere. Where is it? Hold on a sec. Guess I'll find that later. Okay, let's clamp some of the... to bias the amplifier, we only need to clamp the output transistor to the heatsink. We don't need to clamp any of the others for now. The thing I'm looking for is one of these little things. I didn't notice that they were on the heatsink originally, and so when I put the heatsink down on the floor, they kind of fell off, and I was like, oh cool, I'll grab those in a bit. Finished my stream, forgot about it. So the other one of these will be on the floor somewhere. So, but I'll grab those in a bit. I just want to temporarily clamp down these output transistors so that we can bias the amplifier together on the stream. Okay, there we go. Standoffs, James, yes, that's the word I was looking for, standoffs. Have you ever thought of going into the UPS business? I'm not sure what you mean, what, like the couriers? or the uninterruptible power supplies? So this biasing doesn't apply to Class D. No, there's no biasing with Class D. Because in Class D, the two banks of MOSFETs, the high side and low side, don't get turned on at the same time. There's no overlap or anything like that with how it works. It's very different. If there is any overlap between the high side and low side, then you'll soon know about it because everything will be on fire. UPS are basically amplifiers in a way. The power supply in car amplifiers is effectively a UPS in itself. My UPS got blown up by a shoddy repair company in Wembley. Wouldn't even fix the issues they caused. Well, damn, that sucks, man. That really sucks. So is this a UPS for a computer, like a PC? A server UPS. Yeah. Thanks for jumping on, Annabelle. Thank you very much. We'll see you later. Appreciate you coming onto the stream. Hopefully the repair of this helped you out a little bit with your one. Okay. So that's all of the output transistors clamped down to the heatsink, keeping them nice and cool, and also transferring any heat they do generate to the bias sensing transistor that is also mounted to the heatsink alongside them. So, in order to bias this amplifier, we need to take our oscilloscope. We need to probe each of the outputs for each channel. So we're going to start off with the left channel. So let's hook my oscilloscope probe onto the left channel output, which is on this transistor leg just here. Just a nice easy place to clip it. Okie doke. Now what we're going to do is we're going to power the amplifier up and we're going to inject some signal. And the signal that we're going to inject is going to be probably 20 kilohertz. Nice high frequency. Some people say you need to load the amplifier with like its minimum rated impedance for this, but honestly from my experience of doing that versus not doing that, it doesn't actually seem to make a difference as to where the bias position is. So okay, so yeah, let's power this up and let's just confirm that it still makes good audio after replacing the transistors on this side and also going back in the heatsink. It shouldn't have changed, but just want to make sure, double check. Oh heck, okay, something's not happy. Well, that sucks. What's going on now then? Why is it drawing a bunch of current? Okay, we've got a lot of DC on the channel with the transistors that we just replaced. Why is that? Oh, I'll tell you why that might be. One of the things I didn't actually check was that all the emitter resistors and stuff for the ones that failed over here were intact. So let's go ahead and just make sure that no other resistors on this channel are bad. When we were testing it a moment ago with just one transistor fitted, obviously we just had one transistor fitted, so nice low resistance there, resistance there. Yep. Okay, all the emitter resistors are all good in the hood. All of those are paralleled. So what's the issue here then? What's the issue here then? Why have we got excessive current draw over here? The hissing noise is basically the power supply complaining because the voltage has dropped too low. So my bench power supply here is limited to about 4 amps. So if the amplifier tries to draw over 4 amps, then in order to maintain 4 amps, it drops the voltage to the amplifier under like 9, 8, 7 volts, etc., which obviously the amplifier is going to complain about. So that's what the hissing noise is. $36, $36, $36, $36, $35, $35. Oh no, you're joking me! Fuck's sake. I think... Oh, I tell you what's happened. So when I ordered new output transistors for this amplifier. I ordered 4 TIP35C and I ordered 4 TIP36C. However, you can only buy the TIP36C in a pack of 5. So I actually ended up with 5 TIP36C and 4 TIP35Cs. I had completely forgotten that fact and poured the transistors out onto my bench, and I had counted 4 TIP36Cs, and therefore, because I had 4 of the 36Cs, I assumed that the other 4 were the 35Cs. However, because I didn't actually look at the markings on the 35Cs, one of them is a 36C because that's the extra 5th one that I had to order because they came in a pack of 5. So I've got one 36 in the bank where there should be a 35. So I just need to go and swap that. The voltage and amperage display is black. Oh, that's because when my USB's dropped out, I guess that one hasn't come back in. So let me just reset that camera real quick for you. There we go, that should be back now. Yep, so let's put the 35 in where it should be. There we go. Why don't you use hot air? Hot air for TO247AC parts? Well, that's going to cause more board damage than is necessary. I use hot air for surface mount components, not for huge transistors like this. I have used hot air for through-hole components. I sometimes use hot air to remove dip package chips, like dip package like 074s, stuff like that. 2113s. Sometimes use hot air to remove those. Just makes it quicker and easier. But yeah, for massive transistors with high thermal mass. Nah. Hey Sam, if I wanted to send you something, how could I? Firstly, drop me a message on Facebook, facebook.com/bearvids, and go from there. I mean, for preheat, I do preheat the board sometimes. It depends what kind of board it is. This board doesn't have a lot of thermal mass. It's quite a thin PCB. It's just 2-layer. There's not a lot of thermal mass in here. It wouldn't really benefit me. It would speed things up a little bit. If I was going to be doing a lot of soldering, if I was going to be replacing every transistor, every single capacitor, maybe, especially the transformer, the terminals, etc. Yeah, preheating the board makes a massive difference, especially with JL Audio HD, Rockford Fosgate amplifiers that are multi-layer, very thick, hugely high thermal mass. Doing soldering work without preheating is a freaking nightmare and takes you forever. So preheating is super important in that case. For just replacing one transistor that I mixed up on this output section, nah, not necessary. Yeah, computer motherboards as well, very high thermal mass, good to preheat those. Okay, that should now work. So I guess we'll bias the right hand channel first this time. Let's just power it up, make sure that we get clean audio. There we go, there's some clean audio for your ass. Right. So, in terms of biasing this amplifier then, we have two potentiometers on the board. One for each channel. There's a little white one just here. And what that does, like I said, is that's going to change the overlap between the NPN and the PNP transistors. More overlap means better, lower distortion on the higher frequencies, specifically the higher frequencies. Lower frequencies doesn't make as much of a difference, but for tweeters, like if you were using this amplifier with tweeters, you want a nice, decent high bias. If you're using this amplifier with subwoofers, you could, to be honest, get away with having absolutely no bias whatsoever. Just turn the knob down to minimum and have there be quite a big gap between the transistors turning on and off. You wouldn't even notice it. But for full range, for higher frequencies, it's pretty important. So in order to see this, we're going to go ahead to the scope screen and we're going to turn the frequency on my signal generator up to 20k. 20 kilohertz, please. Set that real quick. Okay, there's 20k. We don't want to turn the volume up too much. 20k is actually quite difficult for amplifiers. They draw a bit of current actually producing 20k. So we're going to go ahead and turn the amplifier on and have a look at this on our scope screen. And of course we're not going to get any outputs because we have the crossover module here selected to low pass. So we're going to bypass the crossover here so that we get full range. Now we get 20 kilohertz. And actually, to my surprise, it already looks pretty clean. The distortion that you'll see will actually be up here and down here. It's at the point where the sine wave changes direction, which obviously makes sense because We're starting to get a bit of distortion now, actually, as we turn. I can see a very faint bit of distortion. There's a little bump just there. And that's where this sine wave changes direction. So one transistor pulls the voltage up to the top, and the other transistor is going to pull it back down to the bottom. So there'll be a bit of distortion there and there. So now, if I go ahead and start turning this bias potentiometer, we may see that distortion change a bit on the scope. I don't know how clear it will be to see, but also in addition to the distortion changing and becoming smoother, the current draw on the amplifier will also increase a little bit. Usually a good sort of like a good rough guide is 0.1 amps worth of extra idle current is usually biased all right. Yes, I can actually see that. I can see that changing on the scope screen. I don't know if you can. I'm going to try and zoom in. I'm going to try and move this into a position that you can really see it. Okay, so hopefully, yeah, you can see it, yeah. So as I turn the knob, you can see that shape of that waveform there does change. It becomes smoother, more rounded, more like a circular shape, as if it was going to carry on as a circle. So that's basically what we're looking for. And we're drawing 1.8 amps idle at the moment. If I increase it slightly, we just want to go up to about 1.9. We can go up to 2 amps. We can add... Actually, I think it's just on the cusp. I think that 1.8 on my ammeter here is probably 1.89 if that had an extra decimal point, extra hundredth of an amp. So I think if we go to 2 amps, that definitely gives us 0.1 at least, maybe 0.12 of an amp extra idle current, and that is now looking like a nice, smooth, clean 20 kilohertz wave on the scope there. So let's go ahead and do the same for the other channel. So let's turn the amplifier off and yeah, switch channels here. Okay, so now we're on the other side of the amp and we want to do the same. So we added about 0.12 amps worth of idle current there on the other side. So we want to match that, do about the same on this one. So let's go ahead and give you the scope screen again. Okay. So yeah, you can see that little distortion just at the top there. Actually, interestingly, we're back down at 1.8. Oh yeah, that's because we took the sine wave out of the other channel, didn't we? Okay, that's normal. So we're up at 1.9. So we want to basically give this about 0.1 amps worth of extra idle current. And then I think a touch more. I want to go just below 2.1. There. That's about perfect. Yeah, that's about perfect. Both these channels now nicely biased. Going to sound great. So I'd love to find the standoff so I can actually assemble this amplifier back in the heatsink fully, and then I'm going to run it on this little Alpine Type S. So just bear with me a sec. I'll try and find it. Computer boards are multi-layers, yeah, massively, really annoying. I have a red Sony Xplod 750 watt amp in protect mode. Is it worth fixing? They're pretty nice amplifiers, but they're very low power these days. It's really up to you whether it holds sentimental value, whether you can fix it, whether you want to pay to get it repaired. It might be cheaper just to buy another amplifier, especially at that power level, but if you want to give it a go repairing yourself, then by all means. I have an old school ZR600 I could send to you for repair runs, fine, idle, then protect. If you're in the UK, Brian, that will work fine. If you're not in the UK, then the shipping will probably cost more than the amp's worth. The distortion should be at the zero crossing and not at the top or bottom. No, the crossover point is not at the... It's not at the crossover point. It is actually at the top and bottom, because the NPN transistor, or the transistors are like sort of for positive and for negative. So if you think about the top of a sine wave, like the first half of a sine wave, it has positive voltage and then negative voltage at the other side of it. So one set of transistors will deal with pushing the voltage up to the top, and then the other one will turn on and pull that voltage down because it's pulling negative, it's pulling down from the top. So you always get on every single Class AB amplifier that I have I've biased, the distortion is at the top and bottom. So at the peaks and valleys of the sine wave, because that's where the two transistors change over, I think. But that would make sense as to why the distortion is actually there. Why does the wave become square when turning the amp off? Jason, that's a very good question. The reason that the wave becomes square is because this amplifier has relays, okay, on the board, which isolate the speaker terminals from the main board. So because it has relays, the power down sequence that this amplifier can get away with is actually just to disengage the relays and to have the rail voltage sink down from plus minus 45 volts where it's at a normal operation. It can just have the rail voltage sink down to ground, and it doesn't have to mute the preamplifier section. It doesn't have to mute the audio while that happens because the relays have already disconnected the speaker terminals, so the user will never hear that square wave as it turns off. So we can actually see that in action. If we go ahead and probe one of the channels here that we were just probing, I'm going to turn it down from 20 kilohertz just because it's a little bit nicer to see on the scope. So I'm going to go back down to about what have we got? I'm going to go down to about 200 hertz here. Okay, so if I play 200 hertz on the scope and just kind of calibrate that, let's get that turned on. Okay, so we've got a 200 hertz sine wave here. Now what I'm also going to do is I'm going to take another oscilloscope probe and I'm going to latch that onto the rail voltage. Actually, maybe I can use two different oscilloscope probes and I can latch onto positive and negative rail, but I think my probes are a bit broken at the moment, so I'm not sure if I can. Can I do that one? Right, let's try that. Let's get this one here. Let's latch onto that one. Plug that probe in here. So we've got the sine wave on channel 1, and then I might be able to get the rail voltage on channel 2 and 3. So rail is going to be over here, and also rail is going to be over here. Okay, so that should be rail, and then we're also going to have 10 volts divide, 10, 20, 30, 40. So if I keep it down there, that should work. Okay, DC coupling. 10, that's times 10. Okay, here we go. Unfortunately, they go off the screen. Can I get the rails down a bit? There we go. I'll just turn the voltage down just to get the rails on the screen here a little bit. Okay, 10 volts divide. Right. There, here's a really good visualization for you. So here is the positive rail, okay, up here, and here is the negative rail down here. Here is our sine wave, okay, and okay, the scope is not calibrated exactly here for these probes, but basically the sine wave can go as high and as low as the rail voltage. The rail voltage is the thing that cuts off the sine wave from going any higher, okay. So the amplifier is powered up and playing fully. Now if I remove the remote, okay, with this a clean sine wave here, so this is a clean sine wave playing within the rail voltage limits. If I remove the remote, then the amplifier will turn off and it won't mute the audio. It will disconnect the relays from the terminals, but it won't mute the audio. So the rail voltages, because the power supply section is now turned off, the rail voltages will now start to sink down to ground and it'll start cutting off that sine wave. Watch this. 3, 2, 1. Yep, so that is why you get a square wave on the audio when the amplifier turns off, because the rail voltage is just getting lower and lower and lower, therefore clipping the audio wave lower and lower and lower. You can also see it happen on power up. Look, there you go, there's power up. It builds the rail voltage, and you can see the sine wave starts off clipped, and then as the rails get higher, it then cleans up. And as we turn it off, it then clips it as the rail voltages sink down. The same thing happens in some Class D amplifiers as well, although slightly differently. What switches the relays? There's a relay delay circuit on the board here over by the power supply. It's not just the remote. No, the remote doesn't switch the relays on and off. It's a delayed remote. Sorry, it's a delayed relay circuit. Cool. Right, that's all good and all biased and all working. Now, where the heck is the standoff? It's going to be here somewhere. Because I just plonked it down on the floor, and it should just be over here somewhere. No, I guess I'll have to look for that in my spare time a bit later, unfortunately. It's really weird. It should just be literally on the floor where the heatsink was. No idea where that's gone at this moment in time. Yep, okay. I'll have to reassemble this another time. Let's crack on with something else, another repair. When did you get your 3D printer? A couple of weeks ago. Okay, what shall we do next? I'm going to give you guys a few choices of amplifiers that we can do next. So let's have a look, shall we? See what we got lined up. Let's just try and make a little space on here. Okay, so next we can look at one of these bad boys over here. Yep. So this, let's get the other camera on. This is a Kicker EX 2000.1. I think this would be pretty cool to look at, wouldn't it? We've been looking at Kicker already today, so we can look at another Kicker. How do you guys feel about that? Class D this time, as opposed to Class AB. Ender 5 Plus, yes, this one is stock though, nothing modified on it. Maybe Tom, you can tell me what mods were worth doing and what weren't worth doing on yours. What else? Okay, other options we could look at. I've got this tiny little Vibe. This is a Class D full range 4-channel. So you've got 4 channels of Class D in here. Really rough looking thing. It's been beaten around a bit. Could look at that. Could also have a look at this. I'm not even sure why somebody sent this in. Not really worth very much, but yeah, Sony X-Blood. This is probably going to be this is a 4-channel Class AB amplifier. Not sure what's wrong with this one yet. Haven't looked at it yet. And we've also got one of these. This right here. If I can not make that fall down. I've also got one of these. I've actually got 2 of these that we can look at. This is a Vibe Black Death M21K. So this is a 10,000 watt RMS Class D subwoofer amplifier. It is a Korean full bridge. So we've got, yeah, 2 of these that I can look at as well. There's also a Rockford Fosgate Power T1500 that it works. It creates audio on the output side, but it has a drive circuit fault on one side, and I'm trying to trace it back and trying to find out what the issue with that is. Let's see some Fat Alpine Excursion. Yes, Matthew, we can do that once we've got an amplifier that I can play it on that we fixed. So next amplifier we fix, we'll play it on the Alpine to run it. So I'm pretty keen to do this Kicker because this Kicker is the next one on my list in terms of like when the amplifiers came in from the customers. So I think we'll have a look at this Kicker Class D. Oh, it's already in pieces. So we have the heatsink here. Good afternoon, NSV. Speaking. Yeah, possibly. I've got 5 parcels currently in the hallway that arrived over the last day or so that I haven't opened yet, so it's probably one of those. What did the box look like? Was it white and blue, or...? I think I've got one parcel that arrived that was I think it was white and blue. Haven't opened it yet, but whatever amplifier was in it was not packaged properly at all, and it's actually ripped the box, and the amplifier is half sticking out of the box, probably damaged. So if that was your one, then yeah, it's probably damaged on the way because it wasn't packaged properly at all. It's just kind of floating around inside there with like one layer of bubble wrap. Okay. Yeah, and unfortunately they need lots of layers of padding and foam, as I said in the picture that I sent. Otherwise, yeah, this happens. So I'll have a look at it when I open the box, obviously. I did say to the courier when he dropped it off, I was like, this is a state, and he's like, well, yeah, there's just some heavy item rattling around in there. So I was like, oh, yeah. So yeah, I'll send you pictures once I've looked at it. And yeah, we'll go from there. All right, cheers. Well, at the moment, I've got about, well, I've got this one I'm working on now. 1, 2, 3, 4. I've got about 7 or 8 amps in front of yours, I'd say. What day is it today? Is it Friday? So yeah, maybe like mid next week, I might get around to it. All right, nice one, man. I'll speak to you later then. Bye. This actually looks like a pretty generic circuit design. This is like a Korean board in this kicker. And we also have all of these screws and stuff here. This has been pre-disassembled for me. It's actually kind of useful for the stream because it makes it be a bit quicker. Right then. So this is a pretty standard, oh, I say that, but it's not quite standard. I was going to say it's pretty standard Korean layout. Very similar, very similar. It is got the kicker logos on it and stuff like that. Yeah, it's very, very similar to a Korean half bridge, but these driver cards are not generic. They are actually different. So we've got IRFP 064 ends in the power supply, pretty standard. Got the power supply is 2 transformers, so we've got 3 FETs per push-pull on each transformer. 3 FETs push, 3 FETs pull per transformer, so 12 in total. The drivers for the power supply FETs appear to be surface mount on the power supply driver card. That, I reckon, those are the power supply driver transistors up there. Very bad design. If the power supply section fails, then those drivers catch fire and completely burn the driver card on the power supply. So I think we're quite lucky here. We don't seem to have a power supply section failure. The power supply seems to be intact. On the output side, we've got basically 2 amplifiers that parallel after the inductors, 3 FETs for the high side, 3 FETs for the low side, high side, low side, 2 inductors parallel together. We've got 2 drive ICs. These are going to be a pair of IRS 21844S, I believe, but the drive card is a little different to your generic Korean one that you'd see. We do have the drive ICs on either side. We've got the 3 op amps, not necessarily all op amps, might have 2 op amps and a comparator on here, but then we've got a very different layout of all the resistors and transistors between them compared to your average Korean. I've got the bootstrap pump diode here for the high side, and capacitor, diode and capacitor here for the high side supply in bootstrap. So that's that, and I think we have the feedback resistors from the low side drain to the high side bootstrap supply. One there and also one there. They will be things we need to look at. Got our KA7915 and 7815 regulators over here. So these are going to be for the preamp section op amps. And this one over here is going to be the KA7812, which is going to be supplying 12 volts ref negative rail for the drive ICs. And what's generating the plus minus 5 volts? Ah, there we go. There's plus minus 5 volts regulators for the driver card for the op amps on the drive card. So yeah, 15 volts plus minus, 5 volts plus minus, 12 volts ref negative rail, drive ICs, etc, etc. Yeah, some of the chips are probably sanded off. They tend to do that. So we already have one MOSFET removed here. In the note on the box, it did say one of the MOSFETs was dead. So let's just check the others here. My multimeter cam is also frozen, so let me just go and quickly unfreeze that. Is that your proton blower thing in the bin? Yeah, well spotted. My car had some issues recently, and the interior blower fan actually burnt up, so I removed that and fitted a new one. That's in the bin. So yeah, anyway, let's check these other FETs on here. See what's going on. So the output MOSFETs in this one are FDA 38N30. So this is a 2000 watt rated amplifier. So yeah, 300 volt FETs. We could probably get away with 250 volt FETs, to be honest. Like some 69N25, something like that would probably work okay as well. Okay, so no more shorted FETs in that side. Let's check over here. Really need to get some new probes for my multimeter. Okay, so seems like, yeah, just one FET seems to die because it's been removed. So what we're going to do is we're just going to apply some power wires to this board for a minute, and we're going to pulse the remote a few times, and what that'll do is it will put a little bit of rail voltage in the output section, and depending on where that rail voltage goes, that will tell us a little bit about the potential health status of the drive circuit without actually powering the amplifier up fully, just getting a little bit of rail voltage in the output side. So ground goes in there because of the trace locations. Okay, so power, ground and remote is fitted. Brush off the foam pad, make sure there's no solder or anything that's going to short anything out. Okay, so let's take our oscilloscope probe, zoom in a bit on the y-axis, reject low frequency, 10 volts divide, that's fine. 9.6 volts going in, that's also fine. Okay, so all we're going to do is just pulse the remote a couple of times, get a tiny little bit of voltage built into the output section. So a little pulse then, positive rail is there, positive rail, and we just want to make sure that we don't have any DC voltage on the low side drain over here, which we don't. So that's cool, that's good to see. Got negative rail here on pins 1 and 3 of the low side, that's good as well, that's what we like to see. So I guess now what we can do is we can actually power the amplifier up fully and see whether the drive circuit starts to switch this side or that side or both or neither. So let's give it some welly and see if we get any Class D switching happening. We do. Okay, well, that's pretty simple then. We got Class D switching over there on that side, and Class D switching on that side. So the drive circuit seems fine, just needs some new output FETs. So not really much to diagnose in this one, just other than replacing some output FETs. But it might be a good opportunity for us to have a look at what to do if you can't get the original FETs that come with an amplifier. How do you find compatible alternative MOSFETs? What things to look for in the data sheets, etc. Would anyone like to see that? Yeah. So these are FDA 38N30s. So we can take a little look on the web and see if we can find these in stock, and if not, what do we replace them with? So we have RS components showing these here. Let's see whether they're actually in stock. Oh, to my surprise, they are in stock. Okay, very expensive, £3.50 each. Everything's very expensive now. On Farnell, we are looking at £2.20 each before VAT, which is still a little cheaper than RS. So we're going to need 1, 2, 3, 4, 5, 6. We need 12 of these. Can go ahead and remove these now as we got these. Okay, so that's going to come to £34. Let's have a quick look on Mercatio just in case. They're cheaper on here. From 30, no, that's more expensive, that one, I think. £2.50. Yeah, bit expensive on Mercatio for that one. How about this one? From 10 pieces, a little cheaper, I think, on this one. So let's add 12 to our basket here. One pack is 5 pieces, and I'd need 15 there. So let's go ahead and drop 15 on there. Oh no, 3 packs, not 15 packs. Okay, so cheapest £32 versus, what was it from Farnell? £34. So it's a little bit cheaper on Mercatio. So yeah, if I was to get these, I'd probably order them from Mercatio. But if you want to find alternatives that might be compatible, if you can't find MOSFETs, then the most important factors to look for obviously is drain source voltage. Naturally, you can go higher, but don't go lower. If you're unsure whether you can go lower, then read the rail voltage with 14.5 volts worth of input to the amplifier. Have a look at how far the rails are from each other, and see if you can go drop down. Maybe in this case I might be able to drop down to 250 volt FETs perhaps, but the 300s are in stock, so no need. Aside from that, you want to look at, you want to take a quick look at continuous drain current, but don't get too fixated on continuous drain current, because continuous drain current is how much current the MOSFET can supply, basically fully on, like DC, like turned fully on and just dumping current through the MOSFET, which is not what Class D does. Class D pulses the FETs. So take continuous drain current with a bit of a pinch of salt. It gives you some idea as to how powerful the FET is, but doesn't tell you the whole story. Other thing to look at is look at RDS, which is the on resistance of the FET. And that will generally tell you how hot this FET is going to get when X amount of current is passed through it. Obviously, lower RDS is better, but lower RDS FETs inherently come with other less desirable characteristics, which we'll talk about in a minute. So have a look at RDS. Generally, you want the RDS to be the same as or lower than the part you're replacing, ideally. Once you've looked at those parts, you want to take a quick brief check at pulsed drain current, which is another current rating for a singular pulse. And naturally, Class D doesn't do a singular pulse either. It does a continuous set of pulses at a specific frequency. But the pulse drain current should also be not too much lower than the part you're replacing. So take a look at that. Next, we'll move on to total gate charge. and input capacitance of the MOSFET. The total gate charge is how much energy the MOSFET requires on the gate from the drive circuit in order for the FET to turn on. Lower gate charge makes the MOSFET easier to drive and you require less beefy drive circuit behind it. So that's always good. Input capacitance is how much capacitance the gate has on the MOSFET. The more input capacitance you have, the more issues you're going to have with ringing and with cross conduction when you're driving the output MOSFETs. So generally, if you have a very high switching frequency for full range class D, you want pretty low input capacitance, because otherwise the capacitance of the gate is just going to cause a lot of ringing and it's going to delay the turning on and off of the MOSFET. So if you've got very high switching frequencies, you could get cross conduction between high and low side. So that's never good. Also, take a look at the delay times on the datasheet as well. How long does it take for the MOSFET to turn on and off when given and had its gate signal taken away? Obviously for faster switching circuits, you want low turn on and turn off delays, low rise and fall times. But generally, if you've got a bit of dead time programmed into the circuit, like these class D amplifiers do have a bit of dead time between the high and low side coming on and off, generally you can get away with having slightly slower FETs in. I've used some really slow FETs like 69N25s in these kind of circuits, and there's enough dead time that it doesn't really matter if you've got a bit of a slower FET. But it's just worth bearing in mind if you're having problems with MOSFETs that you've replaced. Have a look at the rise and fall times, and if they're much higher than the original FETs, then that might be a problem as well. And also look at power dissipation. The power dissipation figure of the MOSFET might give you an indication as to the size of the die inside that package. So obviously larger die sizes will be able to dissipate more energy as heat, whereas smaller die sizes won't be able to dissipate quite as much energy as heat, because it can't get the heat out of the die as quickly because it's got less surface area. So heat dissipation is somewhat important as well. You don't want to go much lower on heat dissipation than your original part. How do I prevent a spark when hooking up cables to an amp? Do I need to be concerned of damaging internal components? So Jason, now the spark that you get can be annoying, can be scary to some people. It's not going to damage anything at all. No need to worry about it damaging anything. If you do want to prevent the spark though, what you can do is you can take a headlight bulb or brake light or some kind of 12-volt automotive bulb and put the bulb in series with the power wire. And so just touch the bulb on the amplifier's terminal and then touch the power wire on the other side of the bulb, and the bulb will come on for a brief moment, for a fraction of a second. The bulb will come on and then it will go out. When the bulb has gone out, it means the capacitors in the amplifier are charged. Then when you touch your power wire on the terminal, there shouldn't be a spark. So that's one way of getting around it. Sam, could I pay you to 3D print a proper calibrated box for the Sony 8 with the parameters we got? Possibly, yes. I haven't done any really huge prints like that with the printer yet, so I imagine there'll be some trial and error, and I imagine there might be a few failed prints to start with. It would probably be easier and cheaper just to make one out of wood. Not gonna lie, for an 8-inch sub, for something that big, we're going to be limited on the size of the box with the printer that we've got here. Might just be easier to make it out of wood, not gonna lie. So we could make one out of wood instead if you like. A 3D printer would be better suited for nice looking full range driver boxes or something. Okay, so we don't need to do anything else with this kicker. The kicker amplifier works fine, it just needs a set of new output FETs, nice and easy. So make sure the rail voltages have dissipated. Yep, they have, so we can go ahead and safely touch and remove this now. Yeah, no, Matthew, don't worry about paying me for box design, man. Come around sometime and we'll have a mess around on BB Pro 6, and we'll design a nice box for the Sony, don't worry. It's all good, it'd be good fun. It'd be good fun to do that. We'll go get some wood, make a nice box. And yeah, it should be good. And I can also get some wood to make a box for the dining room sub, for the elemental designs. That'd be nice as well. Okay, so let's put this amp to one side. Now, what do you guys want to see next? I've got a Rockford Fosgate Power Series T1500. That's giving me a bit of a headache on the drive circuit, so we could take a peek at that. This one's probably going to be a long one, maybe, so we'll probably take up the rest of the stream, perhaps, depending on how quickly we find the fault. Like I say, this amp does work. It does produce audio, but there's issues. So we could deep dive on this one if you like, try and get to the bottom of it. We've also got the Sony X-Blood that I showed you, massive Vibe 10K things I could do. I've also got this really freaking annoying little bastard. This this is a Defbonce Apocalypse. It's a tiny little, I think it's a mono. I think it's like a little 800 watt mono, doing some weird ass shiz. Very, very confused about this one. So we could try. This one's going to be long as well if I try and fix that. That's an Ender 5 Plus, that is. What's it doing? I'd have to show you. I don't think I have the words to explain what it's doing. Pick the one you want to work on. I don't know. I don't really want to work on any of these. Not gonna lie. A few people are asking about the Defbonce, so maybe we'll jump on the Defbonce and see if we can get that fixed. It's a tiny little thing. It should be easy, but it's not. All right. 2 AM here. What country do you live in, my friend? A Melbs. 2 AM. That must be like proper over the other side of the world. Alright, let's have a look at this Defbonce then. Kind of thing is, I've already kind of almost exhausted every possibility with this thing. So I'd love to see what the actual problem is on this. Okay, ground goes in there. What's wrong with the Sony X-Blood? I have no idea. I haven't looked at that one yet. Just rolled in. Alright, so this little Defbonce then, what is she doing? Or not doing? Let's have a look, shall we? Right, so power wires are in. Okay, so this is a clone of the Sound Digital circuit. So let me quickly talk you through this circuit, if you're not super familiar with it. So we have power supply MOSFETs on this side, okay? The power supply MOSFET driver is over here. Power supply MOSFET driver, this is like a 4427, for example, something like that. The power supply is run by the MCU, the PIC chip here. This generates pulses for the power supply, goes through the power supply drive IC here. The buffer, before going to the FETs, drives this transformer. The PIC is also responsible for protection circuit, listens to a bunch of different voltages on the board, throws protect if any of them are bad or wrong. The output section is very simple. We've got one MOSFET for high side, one MOSFET for low side. We have a 20957S drive IC here, driving the FETs. We have two rectifiers. We have common anode and common cathode, I think, for the rectifiers over here. A couple of rail caps. This is a dual rail amplifier, so we have positive and negative rail, unlike a lot of them which are just single rail with a floating midpoint. Preamplifier circuit over here, a couple of 074Cs, really basic stuff. We have this voltage reg, which is a 7812, so that is generating 12 volts above negative rail for the drive IC. These are a couple, I think these are a couple of rectifier diodes here for which take an auxiliary tap off of the transformer, which then feeds this voltage regulator. So a couple of little rectifiers here for the 12 volts. Not much else really to say about it. Output inductor, output filter cap. Yeah. I've got a 47 ohm resistor over here. I think that's coupling the output side ground with the main side ground, I think. Well, I'm not entirely sure. But yeah, very, very simple. Very, very simple amplifier. Billy says, Sam, check email. I will check my emails. Actually, I should probably check my phone. I have the schematics for that amp, the 800.1 AAB. Thank you very much, Billy. Appreciate you. Which email address did you send that to? Let me just do a quick refresh on my emails. Here we go. Email come through from Billy. Okay, let's get that up on the screen, shall we? So we can just have a quick look. Okay. Two-factor authentication. Bane of my life. I get it. I get it that it's safe, but oh my god, is it annoying. Right. Schematics. Thank you very much, Billy. Massively appreciate you for throwing through the schematics here. Okay. Let's have a quick peek then. This is an interesting layout for the schematics. We've got different sections here. So we've got this is going to be 7812. This is probably going to be the output side. Is that the output FETs? Where's the output driver? That's the regulator for the drive IC. That's the main transformer. Oh no, maybe this is. Oh no, maybe this is power supply. Nope, this is output, I think. H8. Yeah, this is output. Okay, so these are the output FETs. Being driven by PWM-A, PWM-B, so that's going to be on a separate page. Okay, so this output section, that's your voltage reg for the output driver. That's your transformer. That's your power supply FETs over here. And driven by PWM 1 and 2 as well from the drive IC. Okay, cool, cool. Scroll down a little bit. This is going to be IC5. This is our power supply driver. Okay, cool, cool, cool. IC2 is going to be our MCU, I think. Yep, there we go. IC4 is our MCU. That has all of the identifiers for what pin's doing what and which pins are not used. That's really useful. Thank you very much, Billy. Cool, cool. RCAs. Scroll down a bit further. IC3. IC3 is our MOSFET driver, so that's our 20957S. So yeah, that's cool. See where it gets the 12 volts from the regulator. See bootstrap as well, I think, probably. Yeah, bootstrap as well coming in from IC4. No, that's not bootstrap. That's probably enable or something like that. That's a 4148, so that's not bootstrap. Cool, cool. What's the diode? Okay. Scroll down a bit further. Then we've got what's probably going to be the preamp section. IC1 and IC2. Yeah, there's our preamp stuff. Okay, so yeah, really, really simple amplifier. Right, let's power it up and see what it's doing then. Good afternoon, NSV. Yep, which amplifier is it? Is it a 5-channel or is it a mono? Is it the one that I've been talking to you about on Facebook? Okay, cool, cool, yep. Yep, that's fine. I'm currently live on YouTube though, doing amplifier repair stream, so I can't send the video right now. But I could get it out and test it on stream for you if you like. If you like, I said I could get it out now and test it on stream for you if you like, so you can see it working live. Yeah, it's Barevids, Barevids, Barevids. Barevids. So if you jump on YouTube now, I'm live on YouTube, so I can get your amp out, power it up, and show you it playing if you like. Yep. But yeah, just bear with me a minute because I'm just currently looking at this other little amp. So if you just jump on the stream and then just wait a few minutes, and I'll get your amp out. All right, cool. Speak to you in a bit. Bye. All right, let's really quick look at what this is doing now. I just want to show you what it's doing and what it's not doing. So when we turn the power supply on, get 12 volts going in. Okay. So the way these amplifiers work is that when you apply the remote, the power supply will pulse the FETs and should build a bit of rail voltage. The PIC will then detect that rail voltage, and if it is high enough, it will then allow the amplifier to come on fully. And the LEDs on the side, we have 3 LEDs. We have power, clip, and protect. When we first turn the amplifier on, all 3 of them come on initially, and then we get the protect light go off. Power and clip should stay on, and then when the output side starts oscillating and getting class D switching, then only the blue light should remain on. So when I apply remote to this amplifier, this is all it's doing. It's flickering all 3 LEDs. Okay, now that doesn't mean anything. There is no protection mode or anything like that that would flicker all 3 LEDs like that, and they're flickering at a very low brightness, so they're not really getting much voltage. When you're presented with an issue like this, you shouldn't be fixated on what the LEDs are doing. The LEDs are flickering here because of, they're not flickering because they're designed to be flickering, they're flickering because of some other issue, some other fault somewhere else on the circuit. So if we take a look at the power supply section, then we have the PIC chip here, which is going to be sending pulses to the MOSFET driver here, and then onto the MOSFETs. So let's just see what we've got going on the back of the MOSFETs. Have a look on the scope screen. So we've got our 12 volts there sitting ready to go, ready to be switched, and we're getting these tiny little pulses like this. Not really anything useful, and it's not what the amplifier would usually pulse to turn on. If we probe the gate leg, okay, over here of the MOSFET, we also get some tiny little pulses here. And most interestingly, if we also probe the source, which is just connected to ground, we also get some little pulses or some little bits of noise. We were before anyway, usually. So it's kind of a bit noisy. So we're getting pulses on the drain, a couple of noisy pulses on the gate, and a little bit of noise on the source as well. Now that would usually say to me, oh, there's a ground continuity issue. We're not getting a decent ground connection, but we actually are. I've gone through that and double checked it. The ground is good. We're also getting a little bit of noise back on the positive terminal here. So if we zoom in, you can actually see that there's actually this kind of pulsing noise on the 12 volts input terminal, which is a bit strange. That might suggest that this capacitor isn't doing its job, but yeah, it's a little bit odd. And we're also getting the noise on the negative terminal as well. So let's work our way back down the gate path. So to me, this is saying, okay, we have a power supply drive circuit fault, a remote turn on fault. The PIC is probably not getting its correct supply voltages or anything like that. So the supply voltage for the PIC chip is on pin 1, which is this little pad here. So if we have a look at that, you can see here, this should be getting 5 volts. Every time that the amplifier tries to come on, you can see here that it creates this little dip in this little bit of drop, a little bit of voltage drop. So what that's telling me is there must be some faulty component that is preventing high enough current getting to the PIC when it tries to turn on and initialize. Okay, so I'm thinking, okay, we have an issue with the voltage supply to the PIC that's preventing it getting a good enough voltage, a good enough current to come on and actually work. If we also probe the voltage input to the drive IC, I think it's doing the similar thing. It's actually not doing a similar thing. But if we probe the power supply MOSFET driver, you can see here just a bunch of noise, just a bunch of pulse noise. If we probe some of the other pads along here as well for the PIC, you can see again we've got that kind of falling voltage, that kind of bit of voltage drop there. And if we probe the LEDs, you can see here this is why the LEDs are flickering. It's because we're getting little pulses like this of DC going to the LEDs before it just sort of fails and turns off again. Okay, so that's really interesting. So I was like, okay, there's obviously a problem with the supply to the PIC. So the supply to the PIC is this little circuit here. There's a 10 ohm resistor here which takes 12 volts and acts kind of as a current buffer, as a current limiter. So we've got a 10 ohm resistor here that connects to 12 volts and then has 12 volts on the other side as well. That then goes to this transistor here, and I think this might be a Zener diode. Yep, a Zener diode here, which is basically creating a 5 volt supply for the PIC. And you can see here, if I probe the output and input here of this transistor, you can see here that we have really the same kind of thing going on with the 5 volt supply on both legs of this transistor. That's the output of the transistor. This is the leg that goes to the PIC and should get the amplifier functioning. And the leg that sets the voltage, you can see here, is flickering like this as well. So that's definitely one of the causes of the problem here, is that we're not getting supply voltage to the PIC. However, the most interesting, weirdest thing is that I have replaced every component in this circuit. I've replaced the Zener diode, I've replaced the transistor, I've even swapped the PIC because I was thinking maybe the PIC is dead and is drawing excessive current from this circuit. I've replaced the PIC with a known working one, same issue. The PIC from this amplifier worked fine in another identical amplifier. So it's not the PIC, it's not the power supply drive IC either that was replaced, it's not this transistor, it's not the D23, it's not the 10 ohm resistor, it's not any of the other resistors around here. We've got another 10 ohm resistor just here as well. I think this 10 ohm resistor is in series with the output of the transistor to limit the current that the PIC can pull from the transistor. That's also reading fine. So none of these components seems to be the problem. Okay. Now, let me tell you the real bullshit. Are you ready for the real bullshit about this thing, right? So that is clearly an issue with the amplifier turning on over here. Let me do something really weird for you. Let me turn the amplifier over, turn on my soldering iron. Okay, you ready for this? This is going to blow your mind. You're not going to believe this. Okay, so the issue is the amplifier's not turning on, not getting supply to the PIC. Okay, let me remove the rectifiers. Let's just get a little bit of heat in these first. See, this would be a good opportunity to preheat the board. This actually has quite a bit of thermal mass, this one. That's one rectifier out. You can see how much more thermal mass these boards have compared to the kicker I was working on before, hey? That's the second rectifier out. No solder bridges. Okay, good, good. So now we've taken the rectifiers out. Okay? Now the rectifiers have absolutely nothing to do with this PIC turn on remote power supply drive circuit whatsoever. They are completely electrically isolated from that circuit by the transformer. Now let's see what happens when we turn the amplifier on. Ta-da! The thing works. Obviously it's in Protect because we don't have rectifiers fitted, so it's not detecting any Class D switching. But what the actual heck is that about? Zoom in. We now have, well, I say we have a stable 5 volts on the supply to the PIC, but it's actually not. This is the other weird thing. When the rectifiers are out, although the amplifier does come on, the waveforms for all the supplies are very noisy. But they're only noisy while the power supply FETs are switching. See that? So as I apply the remote, this is the supply to the PIC. Noisy, but then as soon as the amplifier goes to Protect and the waveforms on the power supply FETs stop, then it cleans up. Gets dirty again when the power supply FETs start working, cleans up. If we probe the like this little transistor thing that is responsible for supplying, look, you can see here actually the 12 volts. Look at that. Even if I probe the terminal, right? This is the 12 volt terminal, okay? The 12 volt power terminal. Very, very noisy. Very, very noisy. The ground terminal. Also very noisy. Why is the ground terminal that noisy? It should just be ground. It has a solid connection to ground. What about if I go ahead and probe all the way up at my power supply ground up here? Is that noisy as well? That's not noisy. It's not noisy up at my power supply. So the resistance of this cable is obviously allowing there to be some noise on the terminal due to the resistance of the cable. But what is that all about? Very, very strange. Yeah, no idea. I could try replacing this capacitor. That's the only thing that I've got left that I can think it could be. Or it could also be a transformer problem. The transformer could be leaking, shorting between wires possibly, but yeah, I replaced all of the components in the amplifier's turn-on circuit, the PIC, the power supply driver, the transistor that creates 5 volts for the PIC, etc, etc. Yeah, really weird. Anyway, let me quickly grab this Phoenix Gold amplifier for the customer that just rang me up a minute ago. Show you it working, and we can also satisfy Matthew on the live chat because he wanted to see his Alpine subwoofer moving. So let's go ahead and disconnect this power wires from here. There we go. Put that to one side. Okay, let me just go and grab the Phoenix Gold for this customer. Okay, so this is a Phoenix Gold 5-channel. It's a little 5-channel Class D, not anything that Phoenix Gold has designed. It will just be an off-the-shelf board layout. This came in with a dead output section. It had shorted MOSFETs on the subwoofer channel. It was very, very fussy with what MOSFETs could be used to replace the originals. Like I said, I was talking about earlier with MOSFET replacement models, and I was talking about with higher switching frequency Class D circuits, you do need to be more fussy, more specific with the specifications, the parameters of any replacement MOSFETs you're fitting, because the switching frequency is so high. There's a higher chance for cross conduction between the MOSFETs, and the drive circuit needs to be better optimized the higher the switching frequency is. So let's plug this in and we'll show this playing to the customer. Power, ground and remote, and let's get some wires here for the Alpine sub. We're going to go into the sub channel, as that's the channel that we repaired. Subwoofer input on the RCAs. Frequency generator down to about 30 something hertz here, 30, 37, that's cool. Subwoofer sensitivity. Up a little bit. Guys, the low pass filter for the subwoofer channel goes down to 15 hertz. What's that all about? Why would the low pass filter go down to 15 hertz? The high pass, yeah, sure, no worries. But why the low pass? Doesn't make any sense. Right, let's plug the other end of those wires into this Alpine sub here. And this is a dual 4, so we're going to parallel the coils to 2 ohms. Cool, cool. Yep. So let's power it up. Make sure it comes on. So we have a nice blue light on the top here. Class D initializing, 0.5 amps worth of current draw, and then when all the channels initialize with Class D, we have 1.2 amps worth of idle current draw. A little bit of flex on the sub already with a low gain. Nice blue light on the side, and let's turn the signal up a bit and get this playing some bass. 34 hertz. I think different cameras will look different. There we go. I think this camera looks pretty nice because it's interlaced. Yeah, this camera looks really nice because of the interlacing. So yeah, there you go. Hopefully you're happy with that, Mr. Customer. And yeah, I'll package this amp up and get it back to you as soon as that's been paid. Okay. So guys, do you want to try and diagnose this? Should we try and do this def bonce, the one I just showed you? I do have a identical, fully working one of these. So I have the broken one, and I also have a fully functional one. So if it's possible that this is a transformer, I could actually try swapping the transformers between the boards and just seeing whether that solves the issue. Because really the transformer is kind of the only thing left that I could think could be the problem, apart from maybe that power supply input filter cap, but I wouldn't have thought that would cause those issues that we're seeing. I heard the newer Phoenix Gold amps aren't as good as the older stuff. No, nowhere near. It's not the same company anymore. It's like pretty much a different company now. Have you ever hooked up power and ground backwards before on camera? Yeah, we're all human. It's a very easy mistake to make, especially when I'm live streaming and I'm talking to the live chat. Sometimes it's happened a handful of times. However, fortunately, because obviously we're in the workshop, we have a current limited power supply. So generally I have my power supply limited to about 4 amps at all times. So if I do hook up the wires backwards, the moment that we turn the power supply on, it's going to tell me, "Whoa! I'm trying to dump more than 4 amps here," and it just shows me a big red light. So then I instantly look at it and I'm like, well, turn it straight back off again. So on the odd occasion that it has happened, the amplifier, which has had the wires in it backwards, has received at most 0.8 volts worth of reverse voltage for probably 0.3 of a second. So no damage there whatsoever. The thing that actually dumps the current when you hook it up backwards is the MOSFETs have a diode in them, and the direction of the diode allows the current to pass through them. So basically if you've got a bank of like 28 MOSFETs all in parallel, 0.8 volts at 4 amps for like 0.3 seconds, it's barely even going to wake them up, it's barely even going to notice it. So yeah. Yeah, I don't have RF probes, but every other amplifier here doesn't exhibit those, doesn't do that, doesn't have that noise. Look, let me grab the one that works, right? I'll grab the Def Bonce one that works, and I'll show you how it's supposed to look. If I can find it. It's a very small little amplifier that tends to like to hide around the workshop. Where is it now? Def Bonce! Def Bonce Apocalypse! Where are you? Where did I put you? Did I put you down here? Did I hide you behind my old LGA 775 motherboard? Did I put you up by this Rockford Power T2500? It needs a new output driver card. No. Did I put you by this Bander Viking 15K that needs a new MCU? No. Did I put you next to this Vibe Black Death 10K that keeps blowing up effects in my face? No. Ah, I found you. I put you down by my old 8-inch Lin woofer and my Beats Audio boomboxes. Right. Okay, so here is a fully functioning version of this amplifier. So let's connect some power wires and I'll show you that on a normal fully functioning version you don't have those nonsense waveforms. Actually, if I get some additional wiring, I can actually run both of these amplifiers powered up at the same time. So we can actually just go back and forth between them, which would be really useful. Just got to find which one is got the writing on it. There we go. That one's got writing on it, so that one's ground, that one's ground. Have you pulled this, the 47 ohm and checked it, says Billy. I have replaced that one. It's a brand new 47 ohm. Thomas says lower voltage till it still works. Check for spikes. So these things protect, they'll cut off at about 9.5 volts, I think, and everything, all the noise and everything is about the same, even at the lower voltage. Now I just need a single wire to go between the remotes. So Chris, if the FETs in the SFB get warm or idle, that's likely normal. The drive circuits in those amplifiers are not very well optimized, they're not very well designed, yeah, there is always a little bit of cross conduction on those amps. If they just run a little bit warm or idle, it's probably fine. If the SFB doesn't have 4148 diodes in parallel with the gate resistors, okay, then fit them, because that massively helps. It helps to turn the MOSFETs off much quicker, and it stops that warm or idle issue. So if it doesn't have them, then fit them. Should narrow it down a bit more on the transformer, maybe, but the problem is as the voltage goes down, as the voltage lowers, okay, then so does the voltage on the power supply FET drain, which means that the spikes will lower themselves in amplitude because there's less voltage going into the transformer as we lower the voltage. So I don't think that will really tell us much, but we could try it. Okay, so I'm just hooking up both of these now. I'm hoping that the noise that the bad board is sending back doesn't actually appear on the, doesn't, you know, make its way through to the good amplifier to kind of skew our results, to kind of skew our readings here. But so we've got both of these now. They're both hooked up at the same time, both got the same remote wire, so they're both going to turn on at the same time. So if I power both of them up, let's see what happens. I'm just going to go ahead and quickly probe the power positive terminal on the good amp, just to see make sure we don't get any noise coming through there. A little bit of noise. We just need to pulse the remote a few times to build enough rail voltage in the good amp. Okay, so the good amp's powered on. Yeah, we get a little bit of noise, but not as much. Alright, yes, you can see here, this is the bad amp, okay? Quite a bit of noise on the 12 volt terminal there. But even though it has continuity on the wire to the good amp, the noise is much less. So the noise is coming from here. And if we probe the power supply MOSFET drain wave, okay, this is the important one. Look at how nice the waveform is on the good amp. I'm going to actually probe the gate waveform. So this is the gate waveform. Reject, noise rejection off. I'm just going to try and get it. There we go. So this is the gate waveform on the good amplifier. Looks like it should. Nice clean pulses, square in shape. If we go over to the bad amplifier, look at how terrible these things look. We don't get full duty cycle being built, unfortunately, to really show how bad they look. But they really look bad when they start to build. But just everything looks bad. Look, here we go. This is the power supply waveform of the bad amplifier. And this is the power supply waveform of the good amplifier. They're quite a bit different in terms of noise and stuff. So yeah, we could either try and swap over the transformers. Maybe this transformer's bad. The one thing that I haven't tried changing yet is this capacitor. So I could try changing that and see what that does. I think I might try doing that first. I don't have RF probes, no. But even if this is ringing from the transformer, the good amp doesn't do it. So whatever the noise is part of what the issue is. I think what I'm going to do first is I'm going to try removing and swapping out this cap. Doesn't really show any visual signs of being bad, but it's just kind of something to start with. Oh, another thing. Randomly, the bad amp will sometimes start working with the rectifiers in. So I took the rectifiers out, yeah. So sometimes after I've been sitting here playing with it for a while, sometimes the bad amplifier will magically then turn on and start working. The waveforms will still look terrible, but it will actually come on and play. So 10 volts, right, 10 volts, all right, fine, 10 volts. So what do you want to look at? Do you want to look at the noise coming off of the terminal here? So 12 volts going in, this is how the noise looks. If we go down to 10 volts, noise still looks kind of the same, a little bit lower in amplitude perhaps. As we go up to 13-14 volts, still there, still looks kind of bad. Gate drain, okay. So this is drain at 12 volts. This is drain at 10 volts. This is drain at 9 volts. Noise is all still pretty much there. It doesn't really change. It just goes up and down with the waveform as I increase and decrease the voltage. And the gate. That's interesting. The gate is actually changing in amplitude with the voltage. I don't know if the good one does that as well. Oh, a good one does do that as well, yeah. Yeah, that's normal. Tried any of the exotic filaments? The wood or maybe the conductive filaments. Hang on a minute, my OBS seems to have crashed. 1 minute. Okay, he says, have you tried any of the exotic filaments? I haven't. I've only got my 3D printer like 2 or 3 weeks ago. The 3D printer came with 11 rolls of filament, just like a grey filament. So I'm going to keep using that until it runs out, which will probably be a year or so. So I haven't tried any filaments now. I've literally only had the 3D printer for like a couple of weeks. I'm still getting it dialed in. Twisting the transformer, I did try that. It doesn't seem to do anything, but we'll try and have a little look again. So if I probe the transformer here, let's just get that. There we go. Lots of noise on the screen there. So let's keep that locked in. Give it a good old wiggle around. One thing we could try actually is heating different areas of the board and seeing whether applying heat to any areas changes the noise on this on the screen here. But yeah, it doesn't seem to do anything to the noise there at all. Maybe I'll try heating the board a little bit. So I'm just going to turn the hot air gun on. I'm going to turn the temperature down to about 200 degrees just so we don't sort of start burning, melting anything while we're trying to power it up. But just so it's hot enough to actually make a difference. Congratulations on your Smart 3. Nice one, Kubaz. Hope it does you well. Okay, so lots of noise. Let's first try heating the pick area around here. Doesn't really seem to be getting any better or worse, I can see. How about the preamp section maybe? Just out of interest, I don't expect that to make any difference, but... How about the output section, the driver ICs in the output section? Still kind of looks about the same. Drivers for the output FETs. Still kind of looks the same. How about this big ass cap? What happens if we heat that a little bit? No. So yeah, it's not really doing much. So yeah, let's just do the easy swap. Let's just swap out this cap, just because it's there and it's easy. I'm gonna get the massive, powerful soldering iron turned on. 200, I think 200 watt soldering iron. I'm going to get that turned on because we might want to swap out the transformer, so we're going to need that heated up for the transformer swap anyway. The output has the rectifiers off. Yes, it does. Yeah, the rectifiers are removed, but I just wanted to see if it changed the noise at all. What I'm going to do actually is I'm going to fit the rectifiers back into the board because that gives us a better sense of whether we have made any difference with any of the parts we've replaced, because with the rectifiers in, the amplifier wasn't working at all, which doesn't make any sense. Don't get that. Why would that be a thing? Yeah, with the rectifiers out, the amplifier does kind of try to come on at least, but with them in, it doesn't. So if we put them back in, then we have more of a kind of variance in the operational status, if you like. So that can kind of maybe tell us a bit more about what's going on. Yeah, the chat is quite laggy today for some reason. Not sure why. I think I've got the live stream set to normal latency, which I think is about 40 seconds. I should probably have it set to low latency in the future. I'm pretty hungry actually, not gonna lie. Would love a snack. I am snackless in here, I think. I've got some pistachios that are all over the floor now. Yo, how's it going, Seddon? Thanks for jumping on. So far today, we repaired the kicker, the kicker 600. I can't remember what it was. ZR600, I think it was. Yeah, found the issue with the preamp card on that one, which was cool. Took a quick look at a kicker 2000 watt. Just needed new output FETs, so going to do that another time. Now we're just looking at this Def Bonce Apocalypse thing, tiny little thing. Alright, so rectifier's back in. Hopefully this still doesn't work, because with it not working makes it much easier to, you know, see if the changes that we make actually are making a difference. So let's turn it back on power supply. Okay, yeah, so the amplifier now is not working again. We've put the rectifiers in and it's not working anymore. It's just flickering the LEDs like it was before. That's really good to see. Alright, excellent stuff. So let's go ahead and swap out this cap, just because that's the most obvious thing possibly. Like the first thing that's quick and easy to do that maybe makes sense to check first. Gonna get the mother of all soldering irons here. That was so easy. Does a 5-second rule apply to things in a shell? Nah, not really. They're in like little packages of their own, aren't they? Right. Should we just drop this in the tester and just see what the tester says about it? It's supposed to be 4700 microfarads, 25 volts. Oh, hey, you know what? That does not look good. I might have hit the nail on the head here with this. Nowhere near the correct capacity. We're down at 1500 microfarads. And look at that ESR, 0.14 kiloohms. Bye-bye. That might have literally been it. It might have literally just been that cap. And I sat here for hours the other day swapping out the MCU, the drive IC, the diodes, Zener transistors, all kinds of nonsense. Okay, so oh, I just threw that in the air, but what it was, 4700 microfarad, 25 volts. I'm definitely going to have some replacements for those somewhere. Let's have a look. Got a bunch of caps all up in here. I did have an absolutely massive bag full of ideal capacitors for this. I'm not sure what I've done with them now. Have a look in here. I've got a whole load of 2200 microfarad, 25 volts. These are much smaller. I don't really want to do something janky and parallel a couple of them together. I'd like to just fit one cap in place. I might have to buy a new cap, buy some replacement caps. That's a 4700 35 volt. That's massive though. Same as that one. That's a 35 volt. That's a 3300. We can't be too tall on this board, and we can't be too wide either, because of where it fits. Okay, just for testing purposes, let me parallel a couple of these 2200s yeah, just see if the amplifier starts behaving itself with these new caps fitted. I suspect it probably will. Do the symptoms make sense now? Kind of, possibly, yes. When I saw the noise making its way back to the power terminal, I was thinking, well, that cap surely can't be doing its job, but then also it didn't look like it had it didn't look bad. It didn't look like it was bulged, or like, these are relatively new amplifiers. There should be no reason for that cap to really fail or to go bad. These are not old amplifiers. So I kind of dismissed it as like, because it's super uncommon as well. It's super not common for the capacitor there to fail, so there we go. There's one. This is a really high thermal mass trace, this bit, because it's the ground trace. There we go. So just as a temporary quick test, I'm just going to parallel a couple of these caps together to get us back up to about 4700 microfarads. It's going to be a little bit less than that, but it should be fine. Okay, so there's a couple of 2200s in parallel. So yeah, if this works and just comes on, I guess we found the problem. So let's probe the power supply FETs. No way! That is actually doing what it's supposed to be doing now. That's all it was. It's the cap. Okay, well that is one for the memory bank. Noted. On sound digital clones, especially ones that only have one power supply cap like that, if issue with not coming on and all LEDs flickering and noise, then replace power supply filter cap and should all be good. Let's just double check that it does actually come on and start switching the output FETs. Yeah, building rail voltage now as well, which is cool. Ta-da! There we go. Nice. Ah, what a dickhead. What a dickhead of an amp. Sending me round the block with all these things, changing all these parts, and it was just the power supply filter cap, which it literally never is. And almost every single other amplifier that I've worked on works perfectly fine without even the power supply filter caps even fitted. I've had some amplifiers come in where the power supply filter caps are all vented. They're all vented and bulged and had their shit thrown out. They're basically not even there anymore. The amplifier comes on, plays, works fine. So I didn't expect to see a case where the power supply filter cap being bad would actually prevent the amplifier from even turning on in the first place. That was unexpected. So. Cool, that's good. Happy with that. That's a couple amps that can go back now. Oh, what now? Reassemble it? Nah. What time is it? I'm kind of hungry, not gonna lie. How long have I been streaming for? I have been streaming for not that 3 hours 20 minutes. We can do we can look at the Rockford Fosgate Power series that's giving me a bit of a headache. We can look at the Sony Xplod 4-channel. Don't know what's wrong with that yet. Or I could end the stream here go get a snack. Yeah, what do you reckon, guys? Shall I have a quick look at this Sony Xplod? Because I've actually got to shoot off, not now, but I've got to shoot off probably in about 20 minutes, half an hour or so. Anyway, so I think the Sony Xplod might, hopefully, he says, famous last words, be somewhat simple because it is such a simple circuit, old amplifier. Let's just take the wires out of this. Go get a snack. Yeah, I'll go get a snack. Yeah, I think I'll just take a very quick peek at this this Xplod just because I'm curious. Okay, let's put these to one side. This is the Sony. This is the Sony Xplod. Oh my God! It's the Sony Xplod. So let's crack the back off this. Have a look inside. See what we're up against. Take a quick peek. Literally never ends up with take a quick peek. Oh man, you know me too well. You know how this goes, don't you? You know how this goes. See you later, Billy. Thanks for the schematic. It was really useful to just look through. Oh man, just some tiny ass screw. Why would they do that? They just put some tiny ass screw here, like by itself. Okay. There is a sheet. Okay. Whoa! Okay, wasn't expecting to see this complex city of surface mount components. Heck. It's not quite as simple as I thought. Okay. This is a 4-channel. Is this a... No, this isn't Class D. Okay, so we've got what looks like SOT89 drivers for the output transistors on this side. SOT89 drivers for the output transistors on this side. So we've got channels 1, 2, 3 and 4. This is probably going to be the power supply PWM generator, some kind of 7500 or 494. I think it's 494. There you go. There's a 494. Nice and easy 494. Preamplifier section, op amps, TL072Cs or 4558s, etc. Over there. Rectifiers over here. Voltage regulators for auxiliary supply, op amp stuff, etc. Okay. Let's have a look and see whether any of the output MOSFETs are shorted with my tiny little multimeter probe. Not seeing anything untoward just yet. Okay, no dead output devices. So with no dead output devices, we're pretty safe to throw some power wires in here and see if it comes on. I'm actually really pleased with today's stream. It's nice for things to finally go my way a little bit. The repairs have been really not that great recently. Like, not only, like, some repairs have started to come in, which is nice. However, the repairs that have been coming in have been a bit more tricky than I'd like. So I'm really glad that we got the kicker sorted today. I'm really glad that we found the stupid issue with that def bonds. That's cool. That can go back to the customer now. I'm really pleased that that kicker 2K is a nice simple output MOSFET's job only. So yeah, nice day. Nice day in the workshop. You love to see it. I have to say, I seem to get better luck when I live stream repairs to you guys. Whether it's finding the problem or maybe when I'm live streaming to you guys, I'm more inclined to like not give up or like try every possible reason, try every possible thing that could be wrong. Like for example, with that def bonds amp, I think if I was just repairing that by myself, not streaming it, would I have bothered changing the cap? I kind of do a lot of things sometimes for you guys to show you that something is or isn't the problem, or like to change a part just to be like, yeah, I don't think this is the problem, but let's change it just to see anyway for you know, for your educational purposes. And sometimes that actually ends up helping me find the solution better. Man, this amplifier looks sick. I have never noticed this before. Look on the side of this amp. There's a little button here called test tone. I don't think I've ever seen an amplifier with a test tone button before. So you push that, and I assume it sends a little test tone to the outputs. That's really clever. Never seen that before. Dude. Alright guys, here's a little guess thing for you. What frequency do you think the test tone is? Let's get a little wager going. What frequency is that test tone going to be? Is it going to be 100 Hertz? Is it going to be 1 kilohertz? Is it going to be 5 kilohertz or some random number? What frequency is that test tone going to be? Let's get a bit of a wager going on here. Courage Form says 1000 kilohertz. Well, that's clearly not right. There we go. There's the correction. 1000 hertz. Nice. So yeah, a couple of 1 kilohertz guesses. 440 from Seddon. Interesting. I like that. Guess 100 hertz from Jamie. 1 kilohertz. 120. 440. Yeah, 1 kilohertz seems to be the general go-to. I think 1 kilohertz is the swearing bleep sound, isn't it? On TV. I think it's 1K. Okay, let's get the power supply turned on. I've got 10 volts going in, and let's probe the power supply FETs and see if we have the amplifier turning on at least. Where are the power supply FETs actually? Maybe they're at the back here. I was just thinking actually, the FETs along this side, or the transistors, are probably for the outputs. Yeah, this is output transistors. So whereabouts are the power supply FETs going to be? Are they going to be up here somewhere? Probably up here. Yeah, there we go. There's the power supply FET. So at the top of the board up here. Okay, so let's hit the remote. Okay, not getting anything at all. Ah! This is a really interesting one. Okay. I know what the issue with this amp is already. The thing is just going to be finding it. Yeah, I think I can see it already. Alright guys, this is gonna be a nice simple fix. Yeah, I can see it. I can see it already. So basically, if you get an amp come in and it doesn't power up, no lights, no signs of life, nothing. Start probing around. First of all, take your probe, put it on the power supply MOSFET drain. Should see 12 volts. If you don't, then you've got a continuity issue between 12 volts power terminal and the MOSFET or the transformer, something like that. Hit the remote. Do you see anything? Not really. Actually, there's a little bit of wobble. Can you see a very, very tiny bit of wobble? Okay, interesting. Next thing, probe the gate. I think the gate is going to be this one, maybe? No, is it going to be this one? So the gate is going to be this one. If you probe the gate should have a nice clean PWM. That's not nice clean PWM. That looks like some PWM riding along DC. Okay, so that could be a power supply drive fault. However, if the gate had that much DC on it, referenced to source, the MOSFETs would be turning on and definitely catching fire, which is clearly not happening. So the only reason that can be happening is if the source, which is this pin over here, is also going high with some DC offset, which it is. There's some DC. Now the source pin of the power supply MOSFET should never ever have anything on it other than ground, apart from if you may be working on an MTX or some other weird amplifier that runs the power supply section kind of backwards. But generally, the source leg of the power supply FETs will be connected to ground. If you see anything other than ground, it means that there is a ground trace or ground continuity problem. There's an issue with ground connection between the terminal on the amplifier and the circuit itself. So this should be a nice easy fix. All we need to do is reflow whatever the bad ground connection is. I think it might be here. It's going to be one of these jumper bars probably. So we've got ground coming in here. The connection to the PCB is good there. We've got a jumper bar here. Here, there's some capacitors. And then we have 12 volt jumper bar from there. We probably have a jumper bar going from here over to here perhaps. That, oh, there we go. There we go. There's our bad connection. Let me zoom right in on that so you can see that. Don't know if you can see that there, but see this yeah, you can see the cracked solder there on that jumper bar there. That's our problem. So cold solder, bad solder connection, should be nice and easy. Going to go ahead and reflow that among a bunch of other probably ones just to make sure they're not bad either. There's one over here, doesn't look great either. But yeah, there's a fair bit of board flex in this actually. It's probably not so good for its ongoing health. So let's reflow that, reflow that. I'm also going to reflow a couple other ones over here that maybe could be a bit suspect. And just visually check all of these other kind of heavy mass traces that have a bit of weight hanging off them. Going to reflow all these ones as well, along with that one. These all look like they might have been reflowed in the past actually. Some of these ones over here. Yeah, I think that's probably good to go. Okay, cool. So we should be able to find out what that test tone frequency is now, because I imagine that this is just going to work now. So power supply 10 volts going in, nice low voltage to start with. Probe the power supply MOSFET drain, and there we go. We have operation. Excellent. Amplifier comes on. Now we have a nice clean wave, nothing on the source, and the gate waveform looks good as well. Check for DC offset on all of the speaker terminals, make sure there's no output section faults. Looks good to me. And last but not least, let's figure out what that test tone frequency is. Let's see. So I'm just going to go ahead and probe the output terminal of one of these channels over here. If I hit test tone, oh, I think it's quite a low frequency. 10 milliseconds. What's it going to be? Oh, it's actually maybe. Oh, it's very low in amplitude. I might need to turn the gain up a little bit, perhaps. Might need the preamp section could maybe do with being a bit cleaned up a bit. It's the test tone button is definitely doing something, but it's not actually sending a decent signal to the channels. So let me just quickly clean up these switches and knobs on the preamp board here. I suspect they'll be a bit crusty inside. Might be good to replace them, but we'll just see how the cleanup goes first of all. It's also possible that because this was switched to low pass filter, if the test tone frequency is like 1 kilohertz, it could be possible that the low pass filter was actually filtering it out. So that's another possibility. Yep, let's turn the gains to about 1/3 just to kind of get a bit of signal going in. Off, off, okie dokie. Cool, right, let's see if the test tone button does something now. Oh yeah, there we go. We do have a little test tone. It's very low amplitude though. I wonder if turning the gain up helps. Oh, there we go. Turning the gain up helps a bit. It's a very interesting frequency though. It's kind of two frequencies sat on top of each other. We got what looks like 1.2 kilohertz there, and then we also have a lower frequency, which I'm not sure what it is because obviously it's picking up the higher frequency there. I could probably work it out based on the scope markings, but I'm going to connect a speaker because I want to see what that sounds like. I'm just going to have a little play around with the switches just to see whether it gets louder or quieter with different switch positions. Oh yeah, with low pass filter it actually completely filters it out. So it's before the filter section, that test tone. Okay, interesting, cool. Right, let's connect a little speaker because I really want to hear what that sounds like. Let's hook up one of these tiny little 2-inch speakers, one of the ones here that I was planning to possibly use for my new video series, but I went with one of the others. So let's get a couple of little bits of wire here. Let's hook it up, see what it sounds like. What would you use that tone for installation? Yeah, I guess you could use it to work out which speaker's connected to which wire, perhaps, something along those lines. I don't know really. Trust me to choose the most annoying speaker to try and put wires onto. The tiniest little thing. I'm just going to very quickly solder the wires on. Okay, so yeah, what does that test tone sound like? Let's turn the gains back down a bit. See what that test tone sounds like. We got it into this channel over here. Power on. It pops the speaker quite a lot actually when you release the button. There's actually two different tones playing here. Yeah, it's two tones overlapped each other. If I take my phone out real quick and go to Spectoid, we can see what two tones they are. Cam. Oh, it looks like there might actually be multiple. There's two main ones. Yeah, we've got 1,254 hertz. And then if I low pass filter, then we should just get the low one. If I apply the low pass filter, we should just get the lower one. Yeah, there we go. So we've got 114 hertz and 1.2 kilohertz as the two frequencies that this thing plays as the test tone. Cool, interesting. Hope you enjoyed that. Right, with that said, nice easy repair on this Sony, which it should be, because if that repair took any length of time, it probably wouldn't be worth doing, because this is such a old amplifier that's probably not worth super much. But this is quite a nice circuit in here, quite a nice design, to be honest. You know, it's fine, little 4-channel Class AB thing. It's going to sound alright. Not relatively okay-ish build quality in here as well. Do someone nice for some door speakers. So yeah, pleased that that's up and running again. Let's just remove these wires from this speaker here if I can. There we go, there's one. And there's two. Cool, cool, cool. Alright then, so yeah, I guess with there being two frequencies there, many of you were correct. Those of you who said 1000 hertz were almost correct, and those of you who said 100 hertz also kind of correct. So yeah, good job guys, good job guys. Right, I think that's where we're going to leave it at for today. Really appreciate you guys staying with me for the stream. I love streaming with you guys. It honestly makes my day go so much better and more enjoyable. So I hope you have a great evening or rest of the day, whatever time it is there, great night, and I'll I'll see you soon in either a video or another stream. I'm working super hard on getting my new video series up and running. I'm currently building the scaled enclosure volume, the scaled cabin volume. It's currently in the kitchen waiting for glue to dry. I'm going to paint it, try and make it look sort of nice, but also not caring too much about the aesthetics. So that's going to be that. And yeah, see you in the next stream and video. Take it easy, guys.